Okay, guys, hello. I hope I'm audible. Can someone confirm in the chat? Cool, great. Then, okay, then we'll start in few minutes. Okay, let's wait for others to join. So just open Google Collab. Just search Google Collab in Google. Okay. So how we would be going about this session is, I have a content that I have prepared. Okay. This is an NLP, so we'll start with the introduction of NLP and understand what NLP is. But on the side, meanwhile, we will also be trying to maintain our notebook. Okay, Google Colab notebook will be maintaining, which will have the basics of NLP ready in that. Okay, so that you can refer to the code as well. And in the end, I have a presentation. Okay, so throughout this session for today's, we'll go about the presentation, and in the end, I'll share the presentation with you as well. Okay, right. So that is how we go about. And let me share my other screen, which is a presentation. And okay, so I hope my screen is visible with the presentation. And in order to reply why, yes or no, you can just write y or n, because sometimes I need your uh, need your input, so that just to understand whether you are getting the things or not, or whether should I repeat, or what more we should change. Cool. So yeah, let's start then. And today it's 5th November. We are at 11 a.m. It's a session from 11 to 1. We'll try to take a 5-minute break if needed, right? And yeah, thank you, Ram, for sharing your LinkedIn with me, and others. You can also share if we can connect on LinkedIn as well. Cool. Okay, you can share with everyone. Some if someone wants to share with everyone, they're open to do that. Yeah. Okay, then let's start with NLP. What NLP is, it's natural language processing. Meanwhile, if you have any doubts, I have kept everyone on mute, so that no disturbing sound from anyone else, like from the background, may enter and can't disturb our concentration on the work. Okay, so if in case, that shouldn't stop you from asking. So if in case you want to ask anything, you can just write in the chat. Okay, I'll answer that if that is something which I'm going to take in few minutes, or in the session. So I might skip that, but in the end, if that is not covered, you can just again ping me that. Okay, so that is one thing. Second thing is, if you want to speak, you can just raise your hand, and I'll see on the window that I have opened. So I am using a split screen, as you can see, and on one side I have your chats and everything open, and on the other screen I have a presentation. So that's the thing. And so when you raise your hand, I'll ask you to I'll unmute you, and we can discuss on that topic. Okay, if you want. Cool. So that is how we go about. And without wasting more time, let's start with NLP. Okay, so again, welcome everyone. So these are the topics that we are going to cover in day one. We'll start with evolution of human language. What is NLP applications, its components, process and demo, and then interview preparation and resources and Q&A. So we'll try to wrap this up in day one, that is today itself. And on the day two, we'll build a complete NLP project from scratch. Okay, that's the target from day one and day two. Okay, there is a one small requirement of that you should be a good. So how much experience are you in terms of regular expression? Because I think most of you are passed out. So you must have an idea of the regular expressions. So how many of you have an idea of regular expression? You can write Y or N in the chat. That would be helpful for me. So guys, all those people who have just joined, we are just about to start the session. So if you have joined at the correct time, so you have not missed anything. Ayush has an experience. Okay, seems like everyone has experience, because 4 or 5 people have responded in the private chat as well. So seems like everyone has a experience in regular expression. Just know what regular expressions are and can handle that, right? Cool, thanks. So for everyone who have joined, We will these are the topics that we'll cover in day one, and this is the topic that we'll cover in day two. So we'll try to wrap this up in day one. If anything remains, like resource interview preparation or something, we can shift it to day two, and then we can have an LP project. So there is a lot of scope in day two as well. Cool. Anything you want to ask, the chat is always open to you. You can type me in the private, you can type me in the public. Okay, you can raise your hand, I will ask and mute you. And yeah, then knew something about redaction, that would be more than enough. Also, I'll we would require that tomorrow, so I'll send you a link so that if every one of you can dedicate some of your important and valuable time on rejects, that would be really add and value to to your profile, to your project. So I'll send you the proper link, and yeah, if you can go through, that would be really great. Otherwise, with your little knowledge, I think that would be more than enough for what we require to tomorrow. Just you should know in regular expression that how to create a string of which contains some characters, some particular characters, how to replace few things. So that is all we require, right? Okay, cool then. Uh, let's start with day one. Okay, that is evolution of human language. And anything you want to ask, chat is open for you. Cool. Then, so without any further delay, let's have a look at the agenda that we have already seen. Now we'll move to, yeah, evolution of human language. So the success of the human race is because of our ability to communicate, right? That's it. That is information sharing. Using this ability, we have marched ahead of other animals and have become the most sophisticated creatures. And this is what differentiates us among all the other animals we begin to look for. So we begin to look for ways to preserve our thoughts and feelings and messages, all those things, and other information. We started with oral communication first, like other animals do right now as well. But because of its informal nature, we begin painting on the walls and caves. Right? You have must have seen Ajanta caves and all those things. You must have seen, right, in like in real life or in somewhere in Google something, right? Where we are, where we live now, there was a need to standardize the drawing so that everyone could understand, and that's where the concept of developing a language came. Okay. However, such many such standards came up, resulting in many languages. With each language have its own basic sets of alphabets, combinations of alphabets. Okay, which are known as words, and the combination of words which which were arranged meaningfully, which became the sentence now, right? Each language has a set of rules based on words and are combined to form these sentences, right? These rules that we name as are called grammar, right? And now I'm not going to take any more time in explaining you guys about grammar and all, right? Now, coming to today's world, according to the industry estimates, only 21 of the available data is present in the structured form, right? Data is being generated as we spoke, as I am speaking there. The Zoom is recording this call, I know, and there might be someone who is taking, there is an option of transcript as well. So my voice is being converted to a text data, and this has been stored in the structured form, right? But only 21% of that available data is present in the structured form, and and it's being generated as we speak, right? Or as we tweet, or as we send message on WhatsApp, let's say Instagram or Facebook Messenger. Okay, and various other platforms. Okay, but majority of the data exists in the textual form. Okay, which is highly unstructured, right, in nature. Now, in order to produce significant and actionable insight from this data, it is important for us to get acquainted with the techniques and the principle of natural language processing that we call as NLP in short. Okay, so let's move on. So let's understand what exactly is NLP now. So natural language processing refers to artificial intelligence method communicating with an intelligent system using natural language. Okay, now it is a part of computer science and artificial intelligence that basically deals with human language by utilizing NLP and its component. One can organize a massive chunk of text data Okay, perform numerous automated tasks and solve a wide range of problems, right? Such as automation, summarization, okay, machine translation, named entity recognition, all those that you can see on the left side of your screen. I'm just going through that. Okay, now we'll learn about all these later in the video, right, or in this session, right? Now the goal here is to process, I would rather say understand the natural language in order to perform some useful task, right? Like making appointment, okay, buying things, spell checking, generating responses, social media monitoring, all those stuff we'll try to do from in this session, right? So now, if you look at the various applications of NLP in the industry, firstly, we have spell checking, which is usually there in, if you can find it mostly in words or the documents readers, right? Even online also you can check, you can go through the spell checking, right? Now, now we have words, keyword search, and it is also a field where NLP is heavily used, right? Now, extracting information from websites or particular documents also require the knowledge of NLP. And one of the coolest application of NLP is the address matching, address in matching, which is basically recommendation of the ads based on your search. Okay, what it does, it analyzes the text of the data which you are already using or searched and matched it with the text data of the advertisement. Like you must have seen, and this has been a controversy from quite years, like the problem that uh, Google has with it, Google Assistant, and there is always a saying that Google is listing everything. You can take this experiment as well. You can sit with 2 3 friends, or you can sit with your family in a closed room, and you can talk about a particular topic. Let's say you want to buy furniture, so you can talk about the furniture in the room for, let's say, 10 15 minutes. And when you open some public website which has ads, like maybe a news website or maybe some coding website which has ads on it, right? And header or a footer or sides layout, it has ads. So it is very high chances that you will see the ads of the furniture, of buying a furniture, maybe Pepperfry or some other company, it may come pop up, right? Or Amazon, something, right? So that's where we say that Google is listing everything. There you can find the videos on internet. So I'm exactly not sure, and I won't comment whether they are listening or not, but there are videos mentioning these things, right? So you can check on YouTube as well. So yeah, that's one thing. And now sentimental analysis is also a very major part of NLP. And other application is speak ignition. uh, here we also here we are also talking about the voice assistant like Siri, Google Assistant, uh, Cortana. Okay. Also we need to thank Apple for creating the first voice assistant, that is Siri now, right? We have the implementation of the chatbots. Most of you guys must have used the customer chat services provided in various apps. Like most of these apps use the chatbot, which in itself uses the NLP to process the data, uh, then provide a response based on the input. That is also an application of NLP. Now another application of NLP is machine translation. Most common example is Google Translate. As you know, you now it uses NLP to translate the data, okay, or I would say a text from one language to another language, and that too in the real time. So it has helped us. It might, you might have used that stuff as well, right? Okay, I hope everything is crisp and clear till now. It's all theory that we need to pass, and once we are back on the track with the examples and the coding part, then where the starting part, the interesting part starts. Okay, cool. Now let's see the components of NLP. So NLP basically consists of two components. One is NLG and another is NLU. So NLG is natural language generation, NLU is natural language understanding. Okay, let's move on. So Now understanding the natural language involves mapping the given input in natural language into the useful representation and analyzing different aspects of the language. We'll see what it exactly means, how it means in the code form of code and everything. Moving on to NLG, it involves mapping the given input in the natural language into some sorry, yeah. So natural language NLG, yeah, NLG is the process of let's say producing meaningful phrases and sentences in the form of natural language from some internal representation, right? Now it involves text planning, which include re- retrieving the relevant content from the knowledge base. Okay, it also involves sentence planning, which include choosing required words from the meaningful phrases. Okay, setting tone of the sentence, and finally we have text realization. It is basically mapping sentence plan into a sentence structure. Okay, we'll learn more about this NLG and NLU using the code, so don't worry about that. Now, Uh, so that was a bit of theory part and what definitions we require, what the base we require for going ahead in the NLP. Now let us see what type of ambiguities we face. So usually natural language understanding, which is NLU, right, is much harder than NLG. Now you might be thinking that even a small child can understand a language, right? So how come it is so easy for human beings and it is so easy and it is so difficult for the computer to process it, right? That's what my statement is, that NLU is much harder than NLG. Like generation is easier but understanding of it is harder. And so let's understand what the difficulties that a machine faces while understanding a language. So in natural language understanding, there are certain ambiguities which as you can see on your screen are lexical ambiguity, syntactical ambiguity, referential ambiguity. Now understanding a language is very hard. Taking our English into consideration, there are a lot of ambiguities, and that too at a different level. So let's start with lexical ambiguity then. So lexical ambiguity is the presence of the two or more possible meanings with a single word within a single word basically. Okay, it is also called semantic ambiguity. For example, let's consider the following sentence and let's focus on the italicized rules, right? So the sentence goes like this: she is looking for a match. Okay, so what do you think, what do you infer from this particular line, guys? So is she looking for a match, like as in a match of something, football or cricket, something like that, or is he looking for some partner for like dating match or something like that? So it's not clear from the sentence, right? Now other example, let's take another example, that is the fisherman went to the bank. So is it the bank that deposits our money, okay, that we opens account in, or is it some water bank that a fisherman might go to catch some fish, or to like his boat must be standing there. Oh, so these are the type of ambiguities you can see and you can understand. These are the lexical ambiguities that are English language and we have uh, in terms of NLP, and there the problem is starts. Now, syntactical ambiguity is in English grammar. This ambiguity is the presence of two or more possible meanings within a single sentence or a sequence of words. Okay, it is called structure ambiguity or grammatical ambiguity. You can see. Now let's have a look at these sentences. So the sentence goes like, the chicken is ready to eat. Okay, so is the chicken ready for us to eat, or so this is a kind of, or is it, or the chicken is ready to eat something, right? Now a single sentence can have two meanings, right? Both the meanings may be correct depending upon environment to environment and situation to situation, right? The machine does not know these things exactly, so that's comes the ambiguity for the machine, right? uh, the other example can be I saw the man with the binoculars. So the two meanings of this particular statement can be, was the man having binoculars? Like I saw a man with binoculars, so the man was having the binoculars, or I saw a man with my own binoculars. So these are the two meanings that this particular sentence can go into. Okay, now coming to the third ambiguity, referential ambiguity, which arises when we refer to something using pronouns. Now let's say, let's take this example. The boy told his father the theft. Okay, he was very upset, right? So this is a statement. Now when we talk about he was very upset, so if you focus on the italicized word, he, does this mean that the boy was upset, or the thief was upset, okay, or the father was upset? Nobody knows. This is a, nobody knows, right? So this is called a referential ambiguity. Who he is referring to, basically, he, boy, father, or the thief, right? It's not clear. Cool, guys. I think this ambiguity part is clear as well, right? And you can write anytime in the chat if you think, if you feel anything is not, you need, should I repeat anything or anything like that, you can just write in the chat. Okay, then move to slide 10, terminology. Now when we process text, okay, there are a few terminologies that we need to understand. So the first terminology that we are going to talk about is tokenization. So let's understand to what tokenization is. So it's basically a process of breaking up strings into small tokens, okay, which in turn are small structure or unit or words, right, that can be used for tokenization, right. It involves three steps: breaking a complex sentence into words, right, understanding the importance of each of the words, right, and yeah, understanding the importance of each of the word with respect to the sentence, or produce a structural description on an input sentence, right. So if we take the sentence today, we'll understand tokenization. So let's take the first five tokens. Yeah. So let's not go to example first. Let's open the notepad, notebook, basically. Okay. So I would request you to so I would request you to open the Google Colab in your Google. Just type Google Colab in your Google and you can open. Okay, you can. I hope my screen is visible and you can look into that. I have just said Google Colab, and we have to click on the first link, that is collab.research.google.com, right? Just open that and just let me know in the chat if everything till now is clear, and if everything till now is clear. This is also a presentation. This is also a notebook that I've kept open. Okay, so it will open something like this. Okay, I have just renamed my notebook. Okay, so you can rename it from here. Okay, nothing else. I'm closing this. Okay, so it will open something like this, right? Exactly like this, to be specific. Guys, let me know in the chat if you have opened it, or let me know in type Y or N. Like if Y, if you are coding with us on the live, like on the live class, so that I can get an idea and I can wait for some time for you to type. If you are not coding with us, like on the live, you are just watching the video, you can type Y no in the chat, and so that I get an idea how many people are there. Yeah. So why? Mostly it's why, guys. We have 20 people. It would be great if many of you can reply. Yeah, cool. Thank you. Thank you, Ayush, Vaishnavi, everyone. Yeah, it's okay then for to see the video as well. Yeah, and you can try it at your own pace when you get the recording or something. I'll share you the document, although this complete notebook I'll share with you, and also the presentation that I'm showing you. Both the things I'll share with you. So don't worry about taking the notes and all that stuff. Just focus on understanding. Have this for everyone. Yeah. Cool. Cool then. Uh, yeah. So just give me a minute. I'll. Okay, so I hope everyone has opened the Google Colab. So this is a basically online platform. Okay, it has a server with Google, connected with Google, and if you click on this run button, anything you can write your Python code or any code. Okay, and if you click on the run button, starting few commands will take time. Okay, in order to the kernel gets connected and everything. Okay, and once initial few commands are done, the platform becomes super fast, right? So once the what the code you have written is successfully executed, the green tick will something like this will appear. Okay, otherwise it would be a red tick, red one, right? And the error would appear below. Okay, in order to add cells, these are called cells. In order to add more cells, you can just click here, or you can press Control MB, Control plus M plus B. Okay, now in order to run these cells, you need to click on this run button, or you can press Control Enter, whichever suits you, right? So this is all about the Google Colab notebooks. Okay, if in case you are using some, if you are familiar with Jupyter, if you are familiar with Spider, Anaconda, or anything VS Code, you can use that. The code will remain exactly the same, but you need to check on the installation and setting up the environment part, that you have to take care from your side, right? Here it does not require such stuff, so that's why Google Colab is becomes an easy option. There is also a option to download the file, so I can download the file and I can send you once the session ends, right? Cool, then let's start. So guys, there would be few things that will be very theoretical, okay, and that are very specific to NLP. Okay, so please bear with that. Please bear me with on that. Okay, Aditya, you can rejoin. Try rejoining, because I think my voice is a bit clear with everyone else. So that's the thing, Aditya. Cool, cool then. So let's import first few libraries first. So there is NLTK library that we will use, that will have most of the functions of NLP, right? So let's import. We'll import that after this. So import OS, import uh, NLTK. There is a corpus. We'll import that. So nltk.corpus, import that. Okay, now let's run and check whether they are getting executed. Okay, they are successfully getting imported. If in case you get face any issue that nltk is not installed or downloaded, you can just type the command pip installed nltk, pip install nltk.corpus, something like that. Whichever library is not, you are facing a difficulty with. Cool, that is what we needed to import. Now there is a term called corpus, which can be defined as a collection of text documents, right? It can be, it can be thought as just as a bunch of text files in a directory. Okay, or often alongside with many other directories of text files. Okay, they are basically a collection of text files, you can say corpus. Okay, that's what we have imported as well. So now we'll download few text files out of that. Okay, so one text file is so this is the method nltk dot download. Download is the function that you would that we would require to download any corpus. So there are few names of corpus like Brown, Gutenberg. Okay, uh, so these are the some names of the corpus. So uh, let me download the Gutenberg. Okay, so you can Google it. They are just the names of the corpus. Nothing logic. No logic. It's just the name of the corpus. You can just Google the name of the corpuses in NLTK, and you will get tons of names, and you can use them. So I'm just using another already defined inbuilt text file. That is what I'm using. Right now, if in order I want to see what are the words that are stored in Gutenberg. So what I can do is I can just write Gutenberg dot words. Words is the function that will help us. Um, Gutenberg is not defined. Okay, so let's import the brown first then. So nltk dot brown. Let's go for brown then. That might have Gutenberg inside that. So nltk.download brown. Yeah, now let's import brown as well. So nltk, once it is downloaded from corpus, we need to import that. So from nltk.corpus, import brown, and let's check whether this is working or not. Yeah, it is working. It has been downloaded. Now let's see the words that are stored in brown itself. Brown dot words. This, so these are the words that are stored in. There are hell lot of words. There is, you can see there are dot dot dots. There are hell lot of words in brown. Right now, let's download try downloading Gutenberg again. It get downloaded successfully. Let's use the fields. Okay, so there is a term called field IDs. Okay, a field ID is basically a list of the file that make up this corpus, right? So it's basically a list of files that make up this corpus. So corpus is, you can imagine, it's a directory of a file. Okay, and field IDs are the list of that files. Let's say I want to see the list of the files for the Gutenberg. So what I can do is nltk dot corpus Gutenberg dot file IDs. Look, these are the file IDs that we have. Okay, so you can see there are text there in the form of dot text extension. Okay, so let's try to use some text files now. Okay, so let's look into, you have to choose one of those files. Okay, so let's choose this Shakespeare Hamlet. Okay, so we'll choose that. So let me define a variable with the name Hamlet. Any name you can choose. Hamlet seems to be more appropriate at this point. So nltk dot corpus dot Gutenberg dot words. We have seen that till now we have already used dot word keyword. We have used it. It gives us all the words that are inside that. So we want the words inside which text file. So we want it inside the Shakespeare's Hamlet. So I copy this name. I paste it here, and now let's print the Hamlet. What we are getting. Let's print that. As you can. Oh, corpus. It must be. Yeah, as you can see, there are hell lot of words in Shakespeare's Hamlet, right? In .txt file, there are hell lot of words, starting with bracket, the tragedy of Hamlet by. There are hell lot of words. Okay, so uh, let's look at the first 500 words, let's say, of this textual paragraph. So I'll write a for loop for words in Hamlet, and I'll slice first 500. I only want the first 500 words, so I'm using the slice operation. And let's print the, let's say, words, and let's separate the words by a space, and let's end the word by let's say comma, or let's say space itself. Now let's run that. You can see these are the first 500 words. Guys, any issue till now? Anything, anyone, anything? We have not started with tokenization. It's just basics that I am explaining you. uh okay, okay, yeah, yeah, sure. Yeah. Mohammed. So what is meant by brown? Yeah, so brown basically it's a corpus. Okay, as I told you that corpus. What's the starting command? Yeah, this is the starting command, I guess. LLTK dot download brown, right? Yeah. So corpus. Hmm. Corpus are basically defined as a collection of the text documents. Okay, as we take out Shakespeare, Hamlet, and all those things. So they are basically the combination. Okay, collection or combination of the text documents. Okay. or it can be just thought as a like a junk, just a bunch of text files in a directory. Okay, you can think of it's already inbuilt, we have nothing to do with it. Okay, they are already inbuilt and we are just importing it and then does downloading and seeing their words. Okay, and downloading a sub part of them and just printing them. Okay, just we are doing that stuff, right? Cool. Okay, anyone else, guys? If everything is clear, you can just type a yes, why, or yes, that would be very great. Everyone? Yeah. Okay, cool, great, thank you. And yeah, then okay, so yeah, okay, Abhishek, this till now it's fine. We have imported everything. We have seen what NLTK has, what NLTK feature does. They have already inbuilt all those things. So yeah, we are good as of now. But what's next? So what we can do is we can just Google data science, data CINC, data science. We can Google it and let's see. I don't want courses or all those things. So let's go with Wikipedia and yeah. So what we'll do is we'll copy this text, right? Let's copy the first paragraph of it. Would that be enough? That's what I'm thinking. Okay, let's take two paragraphs then. We need some variables now. So let's take two paragraphs. And what we can do is I'll send you in the chat as well what two paragraphs I have taken so that you can get the same results for what I'm getting. Okay, now in these two paragraphs, we can assign, let's make a variable name with the name ds. Okay, and I'll assign them in the string. I'll assign them in a string and oh my god. Yeah. Now you can see I have defined them as a string. I've done nothing. I have just taken a string, random string from the internet, and I have given it the value as ds. Right. You can just copy it as well. I have sent you in the chat. Right. So let us see what the type of DS is. Okay, DS is not defined. I have to run that. Now if I run it. str, that is a string, so it's a type of string. Then our work is done now. So what we will do with this string is we will first tokenize it, we'll break it into parts, we'll then go about cleaning this part. Okay, so we go about doing all this stuff. So let's start with that now. So so there is a sub module or sub library, you can say, with the name tokenize. Okay, so from that there is a important sub module which is called word tokenize. So let's import that. So from nltk dot tokenize, I'll import word underscore tokenize. Okay. Now let's there is another corpus which is called punk, punkt, punkt. So let's download that. So nltk dot download. These are the names of the corpus. You can just Google it and you will find tons of corpus. I am just using what I remember. Okay. And so what specifically about punk is punk tokenizer basically divides a text into a list of sentences. Okay, by using let's say unsupervised learning algorithm. Okay, to build a model for let's say abbreviation words. Okay, and the words that start sentences, all that stuff. So that's why I'm putting punk it specifically. But for playing with there are a hell lot of corpus that you can play with and you can find their values as well. So let's install punct here. Let's run that. It run successfully here. Yeah, perfect. Now let's tokenize that. So there is a function called word tokenize, right? So let's define a variable ds underscore tokens. So ds is a string that we want to tokenize, right? So these ds underscore tokens will contain all the tokens of the word ds. Okay. So let's see how to tokenize that. So word underscore tokenize is the keyword, is the function, and we have to pass the string inside this. And after this, I'll print ds underscore tokens in the next line. So let's run this. Let's run this. And now you can see the complete string has been converted into the tokens. Guys, got the idea? This is how we tokenize a particular word, and these are the tokens: data, sciences, and comma, square brackets, one, two, three, all the stuff, all that stuff that in any string is called, in the string is called a token. Okay, a big token, small token, doesn't matter, right? Okay, now I can't count them manually, so let's use a function called len to count the total number of tokens. So len is the function we would use that for. So len underscore tokens, so it will give us 201 is the length of the tokens that we have, right? Now let's check the frequency of each token. I can see there are many words that are repeating, right? Like brackets are repeating, data is the most common word that is repeating, science is repeating, is that, and these words are is repeating. Okay, so let's see, let's with is repeating, so let's see how many times a particular word is appearing. So let's see the frequency of each token. So for that, what we can do is there is a submodule again, which is called probability submodule, and in this there is a very important submodule which is called frequency distribution. Okay, so we'll import that. So let's try importing that. So from nltk dot probability, we need to import frequency distribution of fric dict distribution, and let's create an object for that. Frequency distribution for frequency freq, yeah, q it is dict. Probability, yeah, sorry, my bad. It would be nl, uh, cannot import freq dic, oh, not dis, dict distribution. Okay, here I have to change again. Small mistakes, yeah. Cool, finally it's successfully executed and successfully done. So what it basically returns, this frequency distribution, what we have created this. So dist is basically an empty string, and what we'll do is we'll store the count of each word in this. Okay, so but it's not a ordinary dictionary. You can't take any other ordinary dictionary. It's a special dictionary. It has many functions. It has many variables that we'll use in the coming cells, right? Okay, so let's try to create a function that will count that. Okay, so what we'll do is we'll go through a run for loop, we'll run a for loop, and what I will do is let's first check that. So I will go through each of the words in the ds token. I'll go through each of the word, field, that, users, scientific, methods, comma, brackets, one, two, three, all those words. I'll go through each of the word. And what I will do is since I can see there are two different words, one is data with capital D, and there is another data with small d, like this. And then there is a data with capital D, then there is a data with small d. But I know these two words are same, right? Cap D with capital D and small d will not make us any difference in terms of NLP when NLP is considered, right? So it's only increasing our computation cost. So what I will do is I also, they are not separate words, so I can't count them as a separate word as well in NLP. So what I want is I want to create a dictionary that that will have something like, I'll show you on a whiteboard what I want to do. So here you can see what we'll do is we'll create a dictionary. This is a dictionary that we have. Okay. And in this dictionary, let's say there is a word coming called data. So I'll store data, and as the key, this is called key, right? And as the value, what I will store is the number of count. Let's say it is appearing 10 times in this particular string. What is string? DS string. Okay. And this is the count that I will store. How many times this particular word is getting stored. Okay. Before that, I want to convert capital word data into small word, like the uppercase into a lowercase. That is what I want to do, right? Lowercase are already like the lowercase. I will count them directly, right? So that is what I want to do first, and then I will so initially this dictionary contains everything in an empty, like this is dictionary is empty, so any word I give to it will have a value as 0, right? If in case I print the value of, at this point if I print the value of any word in this dictionary, it would be 0 because this dictionary is empty, right guys? So I need to increase the counter whenever I encounter a particular word. Let's say what I'm saying is, let's say I have the words like on the screen itself, ts tokens, right? I have a word data, then sign, then is, then n. Okay, then so I what I will do is I will write something like uh, let's say of dictionary of data. Okay, initially it is assigned to 0, so I will write plus equals to 1. So whenever I encounter the word data, I will do I will do this operation so that it will increase the count of the word data. Okay, it gives the count or the frequency of the data word, right? So that is what I will do. So let's try to like, try over it. So let me define a variable with the name word. Okay, so for word in ds underscore tokens, right, we have to go through each word in the ds underscore token, and in that what I have to, there is a dictionary fdist, and in that I have to store this word. Okay, I'll store that word, I'll like increment it as equals to 1. I'll increment whenever it appears, and whenever that particular words appear, and yeah, that's it, I guess, right? But that's not enough, we have to convert the word into the lowercase, as we have discussed. I want to convert that word into the lowercase as well, right? So f dot lowercase is the function for that. Okay, cool. No, not lowercase. We want the function is lower. Yeah. So let's run it and let's see whether, yeah, it's running successfully. So let's see how the dictionary looks like. And you can see the comma is coming 16 times, and is coming 13 times, data is coming 12 times, science is coming 11 times, the square bracket 7 times, closing bracket 7 times. So all these things are coming as many times as you can see. Cool guys. So this is how you can create, you can count the words, how many words are coming when at what times. Okay, how many times. Cool. So that is, once that is done, we I think we are good. So what we can do next is, let's count, let's, if you want to check the count of any word, let's say I want to check if I want to check the count of the word sign, so I will write fdist, and I'll write see, and if I run it, it will return 11, right? Because the count of the word science is 11. Yeah. So it will return that. So any word you want to check the count of, you can check using that. Now let's see, since we have converted every word to a lowercase, and now let's see how many tokens we have reduced to. So we'll print the length of uh, f dist, and let's see how many words we have reduced to. Okay, so now it's 101. So initially, if you remember, there were 201 tokens, and now it has been reduced to 101. So that's what the duplicates things. Okay, we still need to work on the data, because the data is not perfect, because it has square bracket, it has comma. So please understand, in the terms of NLP, do you think any significance a square bracket or a 1 or 2 in such form, that is it written in the data, in the data, our current data, would make any sense and would help us in terms of understanding the language or generation of the language. Okay, it would only make our word difficult, right? Yeah, that's really interesting. And once we go about this now, it the things will getting interesting. And believe me, by the end of tomorrow's class, you will have a very good project. I'll disclose. Let me disclose the name of the project on that part. That is called Twitter sentimental analysis. And so again, all those buzz that is going on around Twitter, so I thought this topic would be a good. And also uh, I thought of, because the crypto market is going down as the day passes by. So as far as I know, my knowledge of things are being considered. So I have thought to keep the word as crypto, the main keyword where we can get the tweets from, it would be the crypto. So let's do that tomorrow, and we'll analyze the tweets. We'll analyze whether the tweets are getting positive, negative, or neutral. What are the types of the tweet? We'll try to plot those beautiful graphs as well, which will help us analyzing the tweets, and we can show, can have and save them, right? So let's do all that stuff. So yeah, cool then. So that's the length of the dictionary average that we have reduced to. Now let's see uh, what are the 10 most common tokens in the data science in this DS token list, or in the string. What are the 10 most common words, right? So I'll create a variable with this fdist underscore top 10. Okay. And for that I'll use in order to get this, sorry, would be underscore, yeah. So in order to get this, I'll use the function called most common. So fdist dot most underscore common. This is an inbuilt function, and how many most common we want? Top 10 most common words we want. So fdist underscore top 10. Let's print that and let's see how what we are getting the result. Okay, so as you can all, we have already seen like comma and data science. These were the words. So top 10 words, top 5 words, top 3 words you can get from this with the help of this, right? So it's very easy to get that. Okay, right. So now there is another concept that we need to learn, and that we need to see in this uh, tokenization domain. That is how to blank line the tokenize. That is a blank line tokenizer is a tokenizer that will use that divides a string into the substrings, right, by treating any sequence of the blank line as a separator. For example, that there in the data that we have taken, in the string that we have taken, there are two paragraphs. Okay, that means there is one line breaker in between. So we want to return, let's say in the paragraph you want to return how many line breakers are there. Okay, so in order to get that, what we'll do is there is a tokenizer which is called blank line tokenizer. Okay, so let's import that first and let's use that. So from nltk dot tokenize, uh, we'll import what we need to import, that is blank line underscore to tokenize, right? And let's tokenize, let's use it on the ds. Okay, so blank underscore ds underscore blank is the new variable that I'm making, and I'll use this function, use the function of it, sorry, as pass ds in it. Cool. And yeah, so it had been tokenized. Now I'll print the length of the ds underscore blank. So it will give me the number of line breakers we have. As you can see, there are two, like there are two paragraphs in that. Cool. So yeah, that was all for what we have for the tokenize, and I'll stop sharing my screen. We'll go back to PPT and let's quickly get there. How fast this operation will be run on the huge text files in real time. Uh yeah. Mm, that I'm not sure, because that depends upon the data, that depends upon the inbuilt computing power of these worlds and the library. So you can check that on the internet, I guess, because if you want the exact time, all these operations are pretty fast. depending upon the GPU you are getting, the system configurations you will use, but they are pretty fast because they are all are inbuilt and they have already been trained on that. So yeah, that's the thing. So yeah, let me share my window of presentation. Yeah, okay, guys, let's get back to the slide as well. Now, coming back to our tokenization part, we have bigrams, trigrams, n-grams. Okay. Now bigrams are the basically the tokens of two consecutive written words. As you can see on the right, it's already mentioned. Okay. And similarly, the trigrams are referred to as the tokens of three consecutive written words, and usually the n-gram is referred to as the token of any n number of consecutive words for n numbers, right? So let's see how we can implement the same using analytical libraries for bigram, trigrams, and n-grams. Okay, let's go back to the notebook again. And yeah, so now let's start with importing. There is a util function that bigram, trigrams, and n-grams, some modules are stored in. So let's import that. So from nltk dot util, we will import bigrams, diagrams, and n-grams. Okay, so let's try to run that. Okay, okay, it's n-grams. Typos, typos all around. Yeah, so it has been successfully imported. Now what we'll do is we'll take a random string, okay, and we'll tokenize it. Okay, so let's take a random string, and I already had an example. uh, okay, so I'll paste that in the chat and you can copy that from here. And yeah, that's a string you can take in for the example. It gives the best combination of other words, so that's why I have already kept that. Okay, so string equals to, and okay guys, then let's create a variable with the name. So it's a quote kind of thing, right? So let's create a variable with the name quotes underscore tokens, because we are going to tokenize it and we would break it into the tokens. So nltk dot, we know now how to tokenize the words, guys, right? uh, we have already done that using the words underscore token function. So I'll copy that and I'll paste it here as well. Word tokenize, and yeah, what we want to tokenize, we want to tokenize the string, the string with the name string, right? Now let's tokenize first. Yeah, it has been successfully tokenized. Now let's see what the tokens are. You can see it, the most beautiful things in the world cannot be seen. Okay, they have been tokenized and they have been tokenized into single words. Now comes the interesting part, and that's why we have jumped to the notebook, that is creating a diagram of these tokens, of those tokens, right? Okay, let's create the diagram then. So let's me define a variable with the name quotes underscore diagrams. And I want to convert what the function I will use is nltk dot bigrams is the function that I will use. And what bigrams, what whose bigram I want to make. So quotes token, the name of the token that I want to create the bigrams of. Okay, this would I want it to be in the form of list, so I'll convert this in the list. Done. Now in order to print that, I'll copy this and paste it here. I'll get an answer. Okay, you can see the all the tokens have been combined with the two tokens. Now they are not more single anymore. They have been combined. Cool. So these are called bigrams because the tokens have been combined to two. Now the same code will go for trigrams. So I'll copy that code. Why to write it again and again. and the same code will go for n-gram as well. So let's first do it for trigram. So trigram, only the spelling of that will change. And here it will change, the function will change, and here the spelling will change. The rest everything will remain same. You can see that they are now the trigrams. Okay. Now let's hear about the n-grams. N-grams, the spelling will change. There is also one thing that will change. In case of buy and try, uh, it's already clearly visible, and that the what's the number of the tokens, the collection of the tokens we want. In case of buy, we want 2. In case of try, we want 3. But what in case of n? So we have to specify the value of n. So there we can pass a second paragraph. That's why n-gram function comes with a second parameter where we have to pass the value of the n. So that's the thing. So we can take the value of n as 5. Let's say, for example, you can take it anything, 5, 10, 15, anything. In the case of 5, therefore 5 words have been getting combined as a single token. Cool, guys. So that is what bigram, trigram, and n-gram is. And let me know in the chat if everything seems good for you till now. If your understanding is any improvement you want, anything you want to share. Cool. Cool with everyone. Great. Yeah, we'll show you, Ram. Tomorrow we'll make a project on it, and on real time, in the class itself, I show you how we analyze that whether the tweets last. Let's say I will take around 1,000 tweets last live active 1,000 tweets on the Twitter. Are they positive, negative, or neutral? That are about crypto, about layoff, about job, about hiring, anything you want to take topic of, right? So we'll take a random topic and we'll do that. Cool. Just wait for building of these basics because it would be required, right? Cool. Great, guys. Can we take a small 5 minutes break? I have been speaking for like more than an hour now. So I have kept my I'll kept I'll stop sharing my screen and we can take a quick 5 minutes break and we'll be back at 12:15. Cool. Cool, guys. It's 12, 10, 12, 11 in my clock, and yeah, thank you. We'll be at 12:15 back, and once you are back you can have some water if you want. Cool, then it seems like everyone else is back, so yeah, let's start again where we left. So I hope my screen is visible for that. In that case, cool, then yeah, yeah, let's start then from where we left. The n-grams and trigrams, bigrams we have covered, right? Cool. So let's take this example, and now if you can see, this is stemming. Yeah, yeah, yeah. So now once we have got all the words, or as I say, the tokens, we need to make some changes to the tokens, and for that we have a process called stemming. Now, okay, what stemming does is normalize the words into its base root form. Okay, so if you look at the words where, just give me a second. Okay, yeah. So all these words, as you can see, all these words are originate from a single root word, that is affect. And now stemming algorithm works by cutting off end or beginning of the words and taking into account a list of common prefixes and suffixes that can be found in an infected word, right? Now this indiscriminate cutting can be successful in some occasion, but on this other hand, it can it can lead to, and it has some limitation and can lead to problem as well. Yeah. So yeah, so what we can do now is we can jump onto the notebook again, and let's see how we can uh, go about this stemming as well, right? I hope my screen is visible with the notebook. And yeah, for stemming, what we need, there are different stammers that are used for stemming in today's world, and that are defined in NLTK library specifically. And we are using few stammers at this point, and every stammer has its own limitation. Every stammer has its own way of working, right? So there is a Porter stammer that we start with. So yeah, so let's import that first. So from nltk.stem, import Porter stammer, right? And pst, and let me define another object for that. So pst equals to Porter stammer, and let me check whether this works fine. Yeah, it's successfully imported, and we have created an object for that. So it will help us in the stemming now. Okay, so let's stem the word having. Okay, let's take a word. So it's pst dot stem. Will let's stem the word having, and let's see what output we get. As you can see, it returns its base word, that is have. It's not always necessary that they would return the base case, but in most of the cases they would return. Again, these, it depends upon two three things. The training algorithm they have been gone through, the words the words we have chosen. Okay, uh, the stemmer that we are using. So all these things, it depends upon. Okay, now let's try it with more number of words. Let's say we pass a list of words. Okay, so words to stem, I would name a variable. Okay, and let's create a list of these words which we want to stem. So let's say give, and giving, and given, and give. Okay, and now what I will do is I will iterate over them and stem them one by one. So let's see how we can do. So words in words to stem. Okay, words is a variable that I've created in words to stem, and let me print after stemming as well. So what I will print is words plus colon, print in this form. Okay, that is what the first was, the give will appear and the stem of the give will appear. Giving will appear and the stem of the giving will appear. Okay, so pst dot stem, and write words. Cool, and let's run this and let's see how it goes. Cool, guys. So I think they have given most of the correct words. Like giving is given gave, but given, it does not give the root word. So again, as I told you, it depends upon word to word. It depends upon the learning data that these algorithms inbuilt have been gone through. So every stammer has its own limitation, has its own advantage and the way of stemming, right? Okay, so let's move on to another stemmer. Let's see another stemmer how it works. So the stemmer that we now see is called Lancaster stemmer. Okay, Lancaster stemmer. So from NLTK dot stemmer dot stem, will import will import is uh, Lancaster stemmer. Okay, and let's create an object for that. So lst equals to Lancaster lan stemmer. Let's create a function for that. Let's see if it works fine. Yeah, it works fine. Now I'll do the same thing. Let's take the same example on the Lancaster stammer and let's see what different Lancaster could have made. Use Lancaster. So I'll just replace it with my object, and you can see it has converted to a more shorter part, right? It is converted to a root word and with the less number of words as well. Right. Cool guys. So this is how the Lancaster stammer works. Again, they have their own limitations. Might in some cases might this be helpful. In some cases might this be helpful. So again, it depends upon case to case. It depends upon the use case. All those things that we gone through. So it depends upon many things. So we can't just say that this stammer is better. This stammer that stammer is better. Yeah, that's the thing. Okay. So let's again explore another stammer and let's see how this particular stammer performs. Uh, so from this stammer that we are going to work is called snowball stammer. Okay, this is very important. Most of the cases we use this. I'm also using this for I would be using this for the next NLP project, the NLP project that we are going to make tomorrow. We'll be using this snowball stammer for that case. So NLTK dot stem, we will import snowball stammer. Yeah, here it is, and I'll copy this because I need to create an object for that, right? But in this case, the one difference is that you have to specify the language that you are writing the code in. Like you will be using the words for English. I'll specify. I'll try to import that, and it gets successfully imported. And the same code I will repeat here as well. Now the object is what I will change, just like I did for the previous case. SBST would be the object for use for stemming. Okay. Now let's run this and let's see. Okay, it gives almost the same result like this PST, that is Porter stammer is giving. But yeah, again it depends upon the words. It in some cases they might give the same result. In some cases they might give the different result. So it depends upon words we have chosen in the data basically. So it depends upon data to data. Cool. So that was stemming, guys. Let me know if you have any doubts in that in the comment and in the section. And yeah, we can jump on to our presentation and we can continue what we were doing and move on to the next part we have. Okay, so stemming is what we have covered. Now, very important part is called uh, lemmatization. Lemmatization is basically the groups. What message I got? Okay, so now what lemmatization does is groups together. It groups together different infected forms of the words called lemma. Okay, it is somehow similar to stemming. Okay, as it maps several words into one common root. Now, one thing to keep in consideration is that the output of the lemmatization is a proper word. So, for example, if we look back to our output given by the Lancaster demo, you can see it has given an output give, which is not a word. Like it has given the word give, right? Not with the e, which is not a word. So the output of the lemmatization is a proper word. And for example, if you take lemmatization of gone, going, it all goes into the word go. Now, again, we can see how it works with some example, and let's try lemmatization using the NLTK library, right? So yeah, let's go back to our notebook as well. So I know it's too much of switching, but that's important really, because learning the theory is not at all sufficient uh, in case of NLP. So that's why we need to switch to. But again, it's theory is also an important part, and it should go side by side. That's the thing. Cool. Then lemmatization is what we are going to study, and for lemmatization, there are two libraries, some modules that we need to import. That is WordNet and WordNet Lemmatizer. So let's do that. from nltk.stem we'll import that. So from nltk.stem we will import mm, word net, and from nltk.stem I'll import word net lematizer word net lematizer. Yeah, that was correct. Yeah, so that's correct. Cool. Now let me create an object for that. So underscore lem be the word for the wordlet wordnet lematizer function. And yeah, the two corpus that I need to download is wordnet and these two. That is I think it was omw 1.4. Yeah, 1.4. So let's download that. So nltk dot these are corpus. I told you there is nothing to remember. Whenever you are using the lematizer, you can download them. Okay, that it's just like that. So wordnet and nltk dot download mm, omw dash 1.4. Okay, let's run this. It's finally imported. It's successfully imported. And now let's lematize a few words like let's lematize the same things. Let's take the same example that in this case as well. Instead of sbst, we what we'll use is word underscore lem. Okay, and we are not stemming, we are lemmatizing. Okay, so we change the function lemmatize. Okay, but rest everything will remain the same. Now let's. Okay, you must be worried that it has given the same letter, but because that words were making sense and the sorting them were not making sense, so that's why they gave the same result. But again, it depends upon the input to input and the data they have been trained on. Cool. So that, but that's we have to understand the logic behind the lemmatization, and that's what the logic is. And that's how the lemmatization is used. Cool. It's a small topic, not much to worried about. Okay. uh, we have one more important topic upcoming next, that is stop words. After this, yeah, stop words must be there. Yeah. So now do you know that there are several words in the English language, as we have seen in our data sets as well, that I was talking about in the start of the session. That was close brackets, open brackets, 1 2 3, all those things, comma, full stops, all those things are such words in the English alphabet. mm, like at, for, begin, gone, no. So such various words are thought of as useful in the information of and in the formation of the sentence, right? They are important in formation of sentence, and without it, the sentence won't make any sense. But these words do not really provide any uh, help in terms of NLP. Okay, so these lists of words are called stop words in a language. Okay, and so you might be confused as are they helpful or not. So in the English alphabet, they are helpful, but in terms of NLP, they are not. So NLTK has its own list of stop words that you can use by importing nltk.corpus. Okay, so we'll again jump back to these are some words that are mentioned on our screen that will stop them. Okay, so let's again jump back to the mm, notebook and see what how we can import the stop words and use the stop words. Cool. Yeah. So let's import the stop words first. So from nltk dot corpus will import stop words, and we'll download the stop word as well. We have to download the corpus of stop words. That's why we would be able to access those words, right? Let's see if they are running successfully. Okay, it's corpus. Yeah, successful. And now let's see the types of the words that are in stop words. So if you remember in the starting few cells, we have seen this function, what we call as words, right? In order to see the words that are stored in any particular corpus, we have used this word function called words, right? So we are going to use it again. So stop words dot words. That's how we write, right? But we just have to mention the language we want the stop words for. So there, in our case, we want only for English. So let's mention English. You can see these are the stop words that we can, like, that are already defined in NLTK. These are the stop words. Cool. Yeah, cool then. And what next? Apart from these few words, like apart from the few words in our language, let's move on back to the our own data tokens. Okay, the data sign tokens that we have already have. Okay, so if you carefully look into this, okay, apart from few words like science, data, interdisciplinary, all these all the other words are usually stop words, or basically I would say that they do not match any particular word, like special digit. They are like uh, special words like special digit characters, okay, which do not generally add value in our natural language processing, and hence we should try them to remove them. Okay, now we would try to remove them. Okay, so all those brackets, commas, or all those things, numbers, we'll try to remove them. And here comes the uh, so first let's see what are the first 10 words we have created this variable fdist underscore top 10, right? It's already defined. And you can see these are the words. So comma is unnecessary, this is off to, all these are necessary, which does not help us, right? So let's remove that. So here comes the use of the regular expression, right? So a very small use of regular expression, don't need too much worry about that. I'll send you a good article so that you can go through the regular expression part if in case you are not able to understand that. Okay, so let's import the regular expression library, that is regex, we call re in the short, we name it. And let's create a string. So what string I'm going to create? So I'm creating a string that matches any digit or any special character. Okay, so you people who already know the regular expression, they might get an idea. So people who don't know, we just have to mention r, and inside the quotes we have to write the all the special characters that we want to create string of. So basically let me create that first. So I'll name it as punctuation. Okay, and I'll write re.compile. Right, compile is a function that we generally use for that. And in the compile function, r and then and special words like these. Mm, all the special characters I'm typing of, then these closing brackets, and then this, and then 0 to 9 close. Okay, so basically I have created a string with the name punctuation that can match, that will help us in matching with any digit or any special character that you can see on in this string. Okay, so any string or anything we want to match with and take whether they are different or not, because we want to remove them, we want to, that's what I have kept here, that are the special character or digits that I want to remove. Okay, so I'm creating a word with a combination of all those things, right? So let's print the ds tokens. Let's see what they looks like. As you can see, these will be removed, 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 these brackets will be removed, right? These square bracket digits, all these things will be removed, right? So let's see that how to remove them. And please be careful, please be uh, please be with me on this, right? Okay, uh, which command, Mohammed? Okay, I think, but I don't know which command you are talking about. If you can clarify more, if you want to if you want me to unmute you, you can raise your hand and I can unmute you as well. Yeah, cool. You can just mention that. I'll take that up. Okay, so yeah, please be careful on that, guys. Everything clear till now? Para 45. Okay, yeah, guys, everything clear till now because we are going to a very important part, and this I need your full concentration on this. So can you type a yes or no if you want me to repeat anything, any doubts, you are aware, you're getting everything, yes or no. Thank you, Ahmad. Yeah, what about others? Yeah, clear, everyone. Cool, cool. Then let's start then. So what we are going to do, so I think you got the idea that we are about to remove the unnecessary words. What are unnecessary words? That contain special character and all those things, from digits and special character, brackets, all those things we are going to remove from this ds tokens. So you can see the ds token that has contained such type of words at very regular interval, right? And we want to remove such words, okay, because they are not at all helpful in nlp. They are just computing our increasing our computation power by gaining one token from our side, right? So let's remove them. So what I will do is, first I'll create an empty list, okay, and then I will append the words without any punctuation in that string, in that list. Okay, please be careful with that. So let me create a list first. Empty list I'm creating. Post punctuation is the name of the list. Now, what I will do is, please be careful. I will iterate over each word in the DS token. I will iterate over each word. First, I will take uh, from the start. First, I will take data, then I will take sign, then I will take is, then I will take an interdisciplinary field that. So I will iterate over each word using a for loop in the DS tokens. Okay. Then I will compare that particular word with the punctuation string, this punctuation string. Okay, and if in case this punctuation string matches with that particular word, okay, I will replace this word in the ds token with an empty string, okay, with an empty character, right? This is my logic. Okay, so let me write the code for that. So for this purpose, for replacing and for comparing, there is a function called sub that we are using. Okay, so let me show you the use for that. So for words in ds underscore tokens, uh, x equals to punctuation dot sub is the function. I'll do an empty character with words. Okay, what I have written, look, iterating over each word in the ds token, iterating over each token with the help of words is the iterator. Words is the iterator. Words will take data, signs, is, square bracket, round bracket, numbers, all these values the word will take. This words variable will take. Now I'm comparing all this with the punctuation mark, and if this punctuation mark is matching, okay, I'm replacing this particular word from the ds token with an empty string. Okay, why I'm doing that, I'll tell you the logic. And if and that particular word will be returned to x. Let's say if it is an empty string, it is being replaced, so an empty string will be returned to x. Okay, if it is a, let's say, mining, so mining is not a stop word, or mining is not a special character. So x, if they are not matching, so mining will be stored in x. Okay, at time of data will be stored in x. Two will be stored, related will be stored in x. Okay, so all those words will be stored, but special character won't. Special, instead of special character, an empty string will get stored. Okay, that's the logic for this. Now once I'm done this, what I will do is, I will push all those words who are not empty inside this list. Okay, so how I will do that? Length of x, if length of x is greater than 0, that they are not empty, then I will append inside this list. So post underscore punctuation dot append x. So I will append those words which are not empty, that are not special characters. Okay, all the special character words were replaced with this empty string, and I'm not pushing the empty string in the post punctuation. So the final list that I have is the post punctuation. Okay, so let me run this, and post punctuation spelling seems to be wrong. Punctuation, I think punctuation is what I've defined. punc punc. Okay, guys, any mistake you can. Uh, in this line it says punctuation dot sub. Punctuation is not defined. I think I have run this. Okay, I forgot to run this. Okay, my bad. Now if I run this, look, it's been successful. Now let's print post underscore punctuation. Okay, let's run this. Okay, cool guys. So now if you look at it, a few brackets are still remaining. I don't know why they are remaining. Okay, square brackets I have not removed. I have these square brackets were the part of the regression. They were the part of the this regression expression. So round brackets I was supposed to remove. This colon, semicolon, question mark, dash, all these things, digits, all these were supposed to remove, and they have got removed. So you can see the numbers are not there. Okay, in this post punctuation there are no numbers, there are no round brackets. Okay, only square brackets are remaining now. Yeah, so we can write a different regular expression for removing that. Okay guys, so that is how we removed all the various numbers and digits and all those unnecessary things from the tokens. Now let's get back to our presentation, and let's see what we have next. Okay, so stop words are done. Okay, now we have POS, that is parts of the speech. So parts of the speech, generally speaking, the grammatical type of the words, the verb, the noun, the adjective, adverb, and article. It indicates how a word functions in meaning as well as grammatically, right? Within the sentence, a word can have more than one parts of speech based on the context in which it is used. For example, if we take the sentence, if we take the sentence uh, Google something on internet. Okay, in this particular sentence, Google something on internet. Here Google is used as a verb, right? Although Google, we know it's a proper noun, it's a company, it's organization name, right? So it's a proper noun, but here it has been used as a verb. We can हम कहते हैं ना, Google कर लो. So Google कर लो, let Google do the Google, okay, something like that. So it is expressed as a form of verb rather than a noun. Okay, so these are some type of ambiguities that uh, we generally face while dealing with the NLP problems and the text recognitions. Okay, uh, the, so these difficulties makes the natural language understanding even much more harder as compared to natural language generation, as I mentioned, because you understand the language generation is pretty easy. So POS tags are usually need to describe whether a word is a noun, adjective, proper noun, pronoun, singular, plural, word, verb. Okay, it is a symbol, it is an adverb. So as you can see here, we have so many tags on the right hand side of your there is a table, right? So many tags and description for the different kinds of words, all the way from ranging from coordinating conjunction to what work, WRP, right? So as you can see, like what we generally encounter is noun plural, NNP, that is proper noun singular, and verb, WB, VB something, verb will use. Okay, adverb will, yeah, WB, that is verb base form or something like that. Okay, verb third person, all these things will encounter. So basically, let's take an example for that. Now let's So in the first sentence that you can see on the right hand side, the waiter clears the plates from the table. As you can see from the starting, if we use the word takes into consideration, uh, the it is a determiner, right? Now waiter is a noun, cleared is a verb, the is again determiner, the plates are noun, okay, from is not defined, and here the is again the determiner, and the table is again a noun again. And if we take into consideration the sentence on the left hand side of your screen, as you can see, uh, the dog ate the cat similarly, right? So similarly, this is a determiner, the is the determiner, dog is a noun, ate is a verb, and again it's a same determinant and the noun. Cool guys, I think it's pretty much clear what POS, parts of the speech, does. And let's go get back to the notebook and where we started everything from. And we'll start the POS. That POS is very interesting, I must tell you, that how a language, how a system can tell whether this is a noun, this is a adverb in a regular sentence. So it's very interesting. And the type how they work, and how we are getting everything in natural language processing. So yeah. So POS tagging in LLTK basically is a process to mark up the words in the text format for a particular part of a speech based on its definition and the context. Okay, so all those things the systems try to take into the consideration. So let's see how POS text works. So sent equals to, let's create a variable with the name sent. Okay, uh, let's take this random statement. Timothy is natural when it comes to drawing. It's some random sentence we take. And now let's split into tokens. I hope you know how to split into tokens, right? We have been made pro in that, right? Yes. So tokenize now, and what we want to tokenize, send we want to tokenize. And yeah, let's do that. Let's see what send tokens we have. These are the tokens we have as expected. So now we want to the POS tagger that we are going to use is the average perceptron tagger. So let's download that. NLTK dot download average perceptron tagger. Okay. Hmm. Then uh, has defined. So let's use the POS tagger for that. Let apply the POS tagger. So for uh, token is the name of the variable, and in send tokens I'll iterate over each token in the send tokens, and I'll apply the POS tagger function. So print NLTK dot POS tag is the function name of the function, and I'll pass token in that. Like this. This is the closing for this, and this is the closing for this print function. Yeah, cool. Let's run this. And you can see Timoth is a noun, is verb, determiner, natural JJ, when verb again, RPR, verb to RBJ. Okay, cool guys. I think POS tagger is clear with you. Just simple POS tag is the function that we have to use for POS tagger. Cool guys. Till now everything is clear. Yeah. Yes. Yeah. Cool. Okay, then we have another topic, a couple of more topics that we are left, and we would be done. Okay, or it would be a good idea to take that tomorrow, because anyway we are not going to complete with that. We have 6 7 more slides that I needed to cover, so it would be a good idea to do that tomorrow, and then we can start with the project. So yeah. Hi guys, very good morning. We can start with, so let me check where our notebook is, and I think we were about to start with NER. Okay, then let's start, and let me share my screen, and I'll, yeah, yeah guys, it's visible.
Yes.
Uh, Thank you. Okay, so yeah, then, so this is what we have covered till now, right? I'll give you a quick recap what we have covered till now. So it's a lot that we have covered. So okay, we have good strength now, right? Okay, so NLTK was the library that we were looking for. So we'll start with we start with the corpus. Okay, we imported few corpuses like Brown, Gutenberg. We imported that, and then we printed the words that are present. Then we take a random string. We generated the token. We use the tokenization method to broke to break down a string into small tokens. Okay, in the tokens we calculated the length, we calculated the frequency they were occurring, so each token, how many times each token is occurring, we calculated that. And after that we calculated how many blank line tokenized tokens are there. Okay, then we took a random string, and we saw the concept of bigrams and diagrams, trigrams, and n-grams. Okay, and then we moved to stammer. Okay, we performed stemming mm, process. Okay, we saw three stammer: Porter stammer, Lancaster stammer, and Snowball stammer. Then then we moved on to the stop words. We saw what are the different stop words that are already defined in NLTK library. And then we uh, moved to the, then we thought that in the token there were some uh, extra garbage tokens, that, or unnecessary tokens, I would say, that in the unnecessary tokens that we wanted to remove. So we tried removing the unnecessary tokens from the our ds underscore token list. Okay, we did that using the sub function. Okay, and then we took a random string, and then we uh, come to the concept of POS, that is part of speech. And then we covered with the help of the function POS underscore tag, we have completed with the POS tagger we have seen, right? So till this point we have seen, right? So our next part was NER, name entity. Let's see that. I'll share my screen, presentation, and presentation screen, and I'll show you. Yeah. So I hope my presentation is visible to you, to everyone, right? Cool. Then, yes, thank you. So this is what we have covered till now. POS, parts of speech, we have covered. Okay. Example we have taken. Now we'll move on to NER, that is named entity recognition. Okay. So yeah, let's start. So now another concept in natural language processing is NER, which is known as named entity recognition, as you can see on your screen. So the process of detecting the named entities, such as a movie, a monetary value, or be it an organization, a location, quantities, a person, okay, from a text, is known as named intelligent recognition. Right. Now, there are three phases of NER. The first phase being the noun phase, identification, okay, which deals with extraction of all noun phrases from the text using dependency parsing. Okay, and parts of speech tagging. Okay, which is POS tag. Right. This was the first phase. Second phase is the name of the second phase is phase classification. Yeah, it's phase classification, and this is the classification step in which all the extracted nouns and the phases are classified into respective categories such as location, names, and much more. Right. Uh, Now, apart from this, one can curate the lookup tables and dictionaries from combining information from the different sources. Okay, and finally, we have the third, that is entity uh, disambiguation. Okay, now sometimes it is possible that the entity are misclassified. Hence, creating a validation layer on top of the result is very useful. Okay, the use of the knowledge graphs can be exploited for this purpose. Right. Okay, so let's see with it with an example. Right. So let's assume the sentence that is visible on your screen, that is Google CEO Sundar Pichai introduced the new pixel at Minnesota Roy Center event. Okay, that's the statement we have. Okay, now as you can see, Google is an organization, Sundar Pichai a person, Minnesota is a location, Henry Center event is also an organization. Okay, thus, this is an additional layer on the top of the POS tagging. So please understand, in the POS tagging, we what we have classified is we take a word. Okay, we'll say, okay, this is you are noun, you are adverb, this is pronoun, this is adverb, this is verb. Okay, all those stuff. But in this case of in case of NER, we take another layer. We go one step above it. Okay, and we go one step above it and we classify them as an organization. If it is a noun, okay, which type of noun? Like in noun there are, it can be a person, it can be organization, it can be location as well. So it specifically classifies everything, but it's not necessary that everything this NER or the taggers that we use, right, for NER are able to classify. They have some limitation, and we have to look into that, what their limitation are, right guys? So yeah, let's start. Let's go to the notebook and let's see how we code NER for that matter. So this is what we needed to cover. So we have covered. So as you can see on the POS tagger, we use the POS tagger, and it's classified Timothy as the noun, is verb, determiner, natural, JJ. So all those things it has classified. Now we want to tell whether this Timothy is a person or not. So this NER, after NER, it would be able to tell. Like there are chances that it would be able to tell like Timothy is a or Sundar Pichai is a person. Okay. So let's write the code for NER. Okay, so before that I need to download few things. Okay, so I'll directly copy paste few steps, right, of downloading. They are installation steps. So I need to import any chunk and I need to download maxent and chunker and words. Okay, these are the corpus that I need to download. I think it might get given error because NLTK is not defined, so we have to run. Because since okay, so this is another important thing that you need to understand. Like from yesterday, our kernel has been disconnected from the notebook, right? So we have to connect the kernel again. So either I have to press on reconnect button every time, or the kernel will get disconnected after some time. And once it get disconnected, right? This is the problem that we face, right? Okay, so let's run this few things we need to run. Otherwise, we'll keep on getting. I think that would be enough. Let's go back and let's run what we were doing. Yeah, let's try to run it again. Yeah, and you can see it will run successfully. Okay, great then, Aditya, everyone. Cool. Okay, so yeah, once these things are downloaded, let me add few cells. Once these things are downloaded, what we can do is we can uh, take a random code or random example. Okay, any underscore sent, Let's take a variable and let's take a string, random string. So let it maybe the US president stays in the White House. Okay, let this be a random statement. And now what we will do is we'll tokenize this, right? So I think you know how to tokenize a particular word, right? A particular like a string. So let me create a variable with name and any tokens, and we'll use word underscore tokenize, right, guys? I need not to explain that after this. Any underscore send, and any underscore tags. Okay, let's do the POS tagging, or before that let's print the tokens and let's see how it's looking, how the tokens have been generated. uh Word tokenize is not defined. Okay, I think the library has not been imported. Then that's a problem when you break down in these kind of notebooks. Now I have to run all those steps. This might give an error. Leave it. I don't want this. I'm running all the installation and importing steps so that the library that I require is what I get. Yeah, I think word tokenize. This is the look. Word tokenize was not imported, right? Now if I run it again, if I run it again, it would work. Yeah, you can see the complete string has been broken down into tokens. Now, once this is done, it has been broken down into tokens. What we need to do is we need to write the POS tagger for this. Okay, so let's write that. So any underscore tags, let's make a variable and that will store the tagger values. So nltk dot POS underscore tag and any underscore tokens. Let's run this. Successful. It will run what it says. Source not found. Okay, tagger files we have to run. So taggers I have not run. Taggers. NLTK chunk I have run. POS this I have run. Okay, I need to check what. Okay, download averaged. This we have not imported, so we have to look for this command where it is. We have to run that. Yeah, I think here it is. Yeah, it needs to be run. And let me run few other commands before that. Yeah, I think what else it wanted. Import NLTK is already done. Yeah, so I think it will work. This will work now. Yeah, it's working. And let me print the tags that are getting generated. So let's run that. Okay, so as you can see, the tags have been generated. US noun, president noun, stays verb, in the determiner, white, JJ, house noun, right? All these things have been detected with their proper POS taggers. Cool. Okay, guys. So till this we have already seen and we already know how to do this, right? Now the new part, that is the NER, right? That is what you need to do. So it's a one-liner code, just like its tokenizer and its tagger. Okay, so let's that write that one line. So any underscore NER, okay, equals to any chunker we have already installed. So there is a function called named any underscore chunk, and we have to pass the tags value. So any tags inside this, and let's print what we are getting the value of NER. This no module name swilling. Um, I think we have downloaded it on the top. Okay, let me run all the commands then from starting. Should run all the commands then. Let's see how all the commands work. It would hardly take 2 minutes, but debugging it every time is taking more time rather than learning, rather than like running all those commands. How every command will be executed successfully. Oh, uh, what's this? It should be POS. It should be DS underscore tokens. Not taken. It should be token. It's token or it tokens. Tokens, I guess. DS underscore tokens. Yeah, we should not be there. NLTK.pos tagger. POS tags. Mm, I don't know what we were doing there. Yeah. Right. The only thing matters for me is to that it should run. Okay, this is not running. It should have run, although not sure. Guys, any mistake you can find? Python doing step by step. It doesn't matter actually because see, I have. Okay, let me run these codes again. Still no module name. Okay, let me search it on. I think pip install will do. But yeah, it's again. Although we shouldn't have got this error. Look, yesterday only I tried it and it worked. Look, it's the same thing. I'll try copy pasting this. I think there was some spelling mistake. Nothing else. It's working fine. Cool, guys. So as you can see on your screen, it's the determiner organization. US is organization. Okay, US organization. It has named. Okay, in this particular statement I'm talking about. So the determiner US organization and White House noun. Right. So all these things it has been determined. So few things it determined as what you call NER, but some things are again in the POS tagger form. Okay, guys. So let me share my screen. So that was the concept of NER, and let's see what more we need to do in after this. So once we are done with NER, yeah. So NER list, yeah. I'll send you. Someone is asking for the downloaded packages. I'll send you that complete code. I've sent in the chat. Okay. Now, yeah. This slide number 18, slide number 18. Yeah. So now, as you can see in the NER entity list, okay, we have a geosocial political group, geopolitical entity. Okay, we have facility, location, organization, and person, right? So as we just saw from the previous example, you can see that we have organization and we have the facility, right? We have it has detected other as an organization, right? So that's the thing, guys. Now, an important thing to consider in NLP is also the syntax, right? And any linguistic syntax is a set of rules, principles, and the processes that govern the structure of the sentence. Okay, in any language, uh, the term syntax is also referred to as the study of such principles and the processes. Right. Let's move on. So we have a set of rules as to what part of sentence should come up at what position. And now with these set of rules, we create a syntax tree uh, wherever there is wherever there is a sentence as an input, right? So as you can see on your screen. So we'll create a syntax tree. I'll show you how syntax tree looks like. So this is an example of syntax tree on your right hand side. Right. So syntax tree is basically, in a layman terms, if I explain you, is basically a tree representation of the syntactic structure of the sentence or strings. Right. Now it is a way of representing the syntax of programming language as a hierarchical tree-like structure. Right. By this structure, this structure is used for generating symbols tables for compilers and later code generation. Okay, the tree represents all the constructs in the language and their subsequent rules. Now consider the statement that the cat sat on the mat, right? And you can draw a syntax tree like this. Okay, okay, guys. So I think that was all from NLP side. Okay, let me know if you have any doubts in the chat, and if no doubts, then we can start with the project as we promised. Yeah, possibly. No, no, no. Aditya, wait. It got resolved. It got resolved. There was small like typo or something. It get resolved. The same code. No need to install anything else. It get resolved. Guys, cool with everyone? Yeah, I think you asked me that. Uh, we'll answer that in the end of the session. Actually, that is something off topic. So yeah, we'll answer that. And guys, cool with NLP? Yes, no. Should we move on to the projects now? Yeah, cool and excited. Yeah, great. Then let's start with the project then. Let's create a new notebook, right? Just like I did just now, and adds many cells in that. Okay, and let's get started with and we'll name the notebook as NLP project. That's what we name the module as. And yeah. Okay, so the project that we are going to see in this particular session is Twitter sentimental analysis using Python, right? That's the project that we are going to see right now. Okay. So what is basically a sentimental analysis? Okay, what is how we integrate Twitter? What's the why we are doing this? So all those questions are need to be answered from my side. Okay, so first thing first, that is what is sentimental analysis. So uh, sentimental analysis is nothing but it's a way of analyzing things. Okay, the sentiments of the people, sentiments of the tweet, sentiments of the comments, and like all those things, right? It's analysis for that. Talking about what platforms we can perform sentimental analysis on. So n number of platforms you can perform: Twitter, Facebook, Instagram, okay, other social posting platforms as well, social media posting platforms. So you can apply all those sentimental analysis on that as well. Now, why we are choosing Twitter? Because it's a hot topic, and what type of tweets we are going to analyze in this particular project. So they would be based on the crypto, right? The topic and the keyword I will search the tweets by would be crypto. You can choose layoff, you can choose hiring, you can choose IT, you can choose automotive, and anything you want to choose, you can choose. Okay, cool. Then yeah. So first we'll start with scrapping of the tweets from the keyword crypto. Right, with the keyword crypto, we'll try to swap as many as 1,000 tweets, right, from the Twitter. Okay, cool. Since the cryptocurrency market was not doing great from last few months, so that's why I thought that this would be a good idea to go on with the sentiment analysis, and let's see what other people are posting negative about crypto, or people are posting positive about crypto, or they are neutral. Okay, so in the end of this project, what our aim is that in the end we'll have a bar plot, will have a conclusion that these many peoples out of 1,000 tweets, these many tweets are positive, these many tweets are negative, and these many tweets are neutral. Okay, this is the analysis, or this is the outcome that we'll get after this particular project. Now let's start that. So so first thing first, we'll use SN scrap library to scrap the tweets for us. Okay, so what I can do is I'll there are many importing steps, there are many import libraries we need to import. Okay, I have already done that, so I'll send you in the chat. Okay, you can also do it in your system. Okay, project is really great, and the end you will feel like anything. Okay, so these are the libraries that we need to import before we move ahead with this. Okay, so I'll import that. The same thing I'll import also, and just one thing we need to add before this, because the last time when I run this set of libraries, it gave me an error saying that suddenly SN scrap might not be installed in your system. So it's always better to add this. So it just add one step, that is uh, pip install SN scrap. Rest everything will remain same, and that I have pasted in your comment in your chat as well as here. Okay, now if I run it, hopefully it will get successfully executed. Let's wait because it will take time. The all the installation is done, so it will take time. Sit back and relax for a minute. Okay, it gives an error saying pip install sn case sn scrap. It should work. Let me do it separately then. It's working here, it's not working here. That's pretty strange. Okay, so do it separately. Importing and installing, do it separately. So once installing of SN scrap is done, you can continue with the importing. This might take time. You can see the green button that's importing everything. Okay, guys, let's do this together. So what I will do is I'll keep on tracking, keep on tracking you. Okay, yeah, it would work, Aditya. Anyways, yeah, it worked. I think, yeah. your that would also work. So what we can do is, once I ran few cells, I'll ask you whether you are done with or not. Okay, so please confirm me in the chat whether you are done with this importing part or not from your in your local system. This is the importing part we done. Okay, Aditya is done. What about others? This is for all those people who are writing the code with me. Also, the other people need to respond, like if they are getting the answer, if they are okay with the steps, if they are not having any doubt. Done. Seems like everyone else is done, right? Okay, cool then. Uh, so yeah, this was the initially first part of installation. Now, what we will do is we'll start with the coding and more logical part. Okay. So what we'll start with, we'll first create a list to append the tweets data. Okay, we'll create a list that will append the tweets data inside it. Okay, so let me create a list for that. So let the name of the list be tweets underscore list. It will be, and let me create an empty list for that. Okay. Now let me we know that I would only take 1,000 tweets because the generating their token, generating uh cleaning them, all these things will take time. Okay, each step will get delayed, right? So, and 1,000 is a pretty good number. It's not very less, it's not very high. It's a good number. So let's take 1,000 then. So we'll make another variable with the max tweets equal to 1,000. So it tells that the maximum tweet that we are going to take is 1,000. Cool. Till now we have done. So we have created a list to append the tweets. We have created a variable to check how many tweets we are going to take from the Twitter. Now, as I told you that using Twitter search scraper, okay, to scrap the data and append the tweets to the list. That is what the next step would be. So we would be using SN Twitter library, right? And there is a function called Twitter search scraper. Okay, so what it basically does, it will scrap all the tweets, or it will take all the tweets data from Twitter to till today, right? So will the date we can specify as well. So will we just need to append the tweets, append all those tweets into the list, empty list that we have created. So let's do that. So we'll create uh, we'll uh, we'll take two variables, I and tweet, and enumerate. Enumerate is a function that will return an object. Okay, and object will contain two values, that is I and tweet. Both the values will be taken. Okay, as in Twitter is the name of the library, and then Twitter Twitter. It must be Twitter search wrapper. Okay, search wrapper. And inside the brackets, what I will write, I'll write the keyword that I am going to use, crypto, crypto, and then we want from 2000, let's say January 1, 2000. So 2020. Yeah, let's say January 1, 2020. So January 1, 2020 until what? Until today. Right? We want all the 1,000 tweets. Okay. So, and the function that we'll use to get the is get underscore items. And get underscore item will return two things, I and tweet. Both variables will be get stored, right? Now, colon. And now what I will do is I will check whether uh, I'll check whether I is greater than max tweets. Okay, that is maximum tweets that we have, that we want to take. Okay, if I becomes greater than that, so we'll break the loop. Okay, otherwise what we'll do, we will push all these tweets into the tweets list, tweets underscore list. Okay, so let's put that tweets underscore list. Sorry, tweets underscore list append Tweet dot content. Okay. Okay, guys. So we are done with this. Oh, it's enumerate. Enumerate. I have spelled it wrong. Hmm. Enumerate. M E will come. Enumerate. Yeah. Now it's maybe correct. Okay. Yeah. It will. Bracket will come here. Enumerate will close here. Get in will obviously there. Enumerate is the function that is iterable. Oh, get items. Get item is not a function. We have not created get item as a function. Too many mistakes. Yeah, finally we are getting few things. Yeah. So our list is ready, and let's see how our list looks like finally. Tweet underscore list. Oh, it's an empty list. Let's check that. What happens? Oh, list dot append. What's happening? Too many typos. Okay, still empty. Tweet dot content. Inside this for loop, we have written I tweet. Tweet dot content is there. Tweet dot content is there. Until today. Oh, it's a. It must be 0101. We have missed a dash. Okay, that's strange, guys. Any mistakes you were able to find? Okay, the name SNS tweet is Twitter is not defined. Uh, you are getting this error. Okay, okay, cool. I have seen this error. I have seen this error, and just Google it, Rungali. You will find the solution for that. There is a click on to search on Stack Overflow. Search on Stack Overflow, and you will find your answer. It's yeah, it will be resolved. Guys, anyone can find any typo that we have done here. There must be any typo only. We can't have because there is nothing we can do wrong in that. I comma Twitter in enumerate SN Twitter dot Twitter search scrapper. Your Twitter search scrapper is correct. Crypto is correct since January 2020 until today. We want the tweets and dot get items, and if I is greater than maximum number of tweets, then I'll break. Otherwise, I will keep on appending content of the tweet. It must get executed. I find an error in the machine. Can't find model and code. Okay. Yeah. So Aditya, what you can do is I'll let me change my screen until it is running. This time it will run. So there is a Stack Overflow that it get it resolved. Yeah. So you can try this link. Okay, I'll send you in the comment. This link has worked. This particular method answer, this particular answer has worked for many. Try that. Okay. It would take some time because there are 1,000 tweets if it is running successfully. If it is taking so much time, that it means that it is running successfully. I think I may be wrong, but yeah, that's what I think. So yeah, we can have a 2 minutes water break if you want. You can drink your water. You can come. Yeah, I'll paste my pasted that. Guys, we can take a 2 minute water break and we can be back here until it's this particular code is running, right? So let's take a 2 minute break and we'll back here. So it's 11:57. Let's be back at 12, right? I have kept my screen shared on only, right? You can see that. You can see the code until it's running. Okay. Okay, guys. I hope all of you are back, right? So yeah, our code has also been this particular cell number 2 has completed now running. Then let's see if we are getting some tweets. Yeah. So we are getting these 1,000 tweets right now. Okay, as you can see on your screen. Now I'm regretting why I printed tweets underscore list because we are about to prepare a data frame for that. So yeah, no worries. So we have got the tweets finally, right? 1,000 tweets are there. Okay, related to crypto. Okay, since to January 2001 till today, top 1,000 tweets are there. Okay, now yeah, so this it is in the form of list and okay, it's worked, Aditya. Yeah, great, great then. If it is working for you, happy for that. So once we have got the tweets, now they are in the form of list, and you might already be aware that uh, we are not able to handle that in the form of list. Okay, for data cleaning and all those purposes, we require data frames, right? Something called data frames, right? And for data frames, you require it's in the pandas library, right? So let's convert this list into a data frame so that we can play with it, right? So let's take the name of the data frame as tweets to data frame, tweets to df. Okay, and what we'll do, we'll write pd, that is pandas we have imported as pd, right? If I show you, I have imported pandas as pd, right? Okay, so pd dot data frame and the data frame that we want to convert, so tweets we wanted to convert, and we'll try to create another and the column name that I want is tweets. Okay, tweets is the column name that I want. So let's run this and let's print the data frame as well. So I'll show you how the data frame looks like. See, oh, that's tweets underscore list. That's not tweet, that's tweets underscore list. List is what we needed. Yeah, I don't know what's happening. Okay, so these are the tweets. Now they are in the form of data frame. Cool. And the column name is tweets as well, right? Our job is done. Half of our job is done. Like we have the data now. Okay. Now let's, if I want to print the first 5 lines of the data, first top 5 tweets I want, if I want. So I hope you are aware of this function dot head, right? And if I run it, see top 5 tweets we can get, right? Now the other step that we'll do is, if you can see in our tweets, there are few there are few strange word, there are at the rates and all those things are there. Okay, it's a language part, but I don't know whether this will not get removed because it's a part of language. Okay, but this at the rate, these mentions and the numbers in the tweets. Okay, and hashtags in the tweets. Okay, the complete tweet will contain also hashtags. All these things are there in the tweets. So we need to clean all these tweets, okay, before applying any NLP or before going for data visualization, right? We need to remove and clean our data. Tweets underscore list, Aditya. It's the list name is tweets underscore listener that we have appended the new list we have made appended, right? Yeah, you can filter region based as well. You can write the keywords. Aditya, got the point? Tweets underscore list is the list that we have been getting. Yeah. Okay. Cool. Then, hmm. So we need to clean those data. Okay, we need to clean our tweets. So I hope you are aware of regular expressions. Okay, if not, I'll in the end of the class I'll send you a good reference of regular expressions, and you can go through that as well. Okay, so in the regex library, in the regular expression we use, there is a library called regex. We use that. Okay, there are a couple of functions, like there is a sub function. Okay, sub function we have already seen yesterday, right? And so let's try to use that. Okay, so let's create a function that will clean our tweets. Okay, so def uh, let's name the function as clean tweets. Clean tweets. Okay, clean tweets. And I'll take a sample text in this as a parameter. And what I'll do is, uh, first I remove the at the rates. Okay. So re dot sub, and I create a string that will remove the at the rates. So at the rates in the any form, like it may contain A to Z, capital A to capital Z, small a to small z, uh, and numbers from 0 to 9, and some underscores as well. Okay. Uh, and plus as well. Now it should replace it with empty text, empty string, and what we want to work on text. Okay. So this is the method of removing at the rates. Okay. If you know regular expression, then only you can understand this. Uh, if you don't know, don't worry, I'll send you a good link, but I can't take regular expression at this session because it would take me another 1 hour, and we won't be able to complete this project. So yeah, that's a constraint we have. But regular expression, it's easy. I'll tell you, and you will get in hardly in 30-40 minutes. You will require when you are itself, you are reading itself. You might skip few things, but while teaching I can't skip those. So 30-40 minutes, in 30-40 minutes you will be able to get it. I'll send you few links for that. Okay, so with this particular line of code, what I have mentioned is I have removed all the at the rate mentions, like at the rate Elon Musk, at the rate something, at the rate crypto, all these things, all the at the rates I have removed. Okay, at the rate my name, at the rate your name, at the rate something, it has removed, right? Cool, guys. So that's the line for removing at the rates. Now I have let's remove the hashtags. Okay, so I have already written this clean tweet function because it was big, so I have already written that, and I'll copy that, and it comes with a proper syntax, so you don't have to worry about what removes what, and it's self-explanatory as well, and I explain you as well. This removes http, this removes rts, this remove hashtags, this remove the new lines. Okay, in the tweets, right? Once this is done, we will return the text. Okay, so we have played the text, we have taken the test, and in the test we have removed mention, we have removed hashtag, we have removed http links. That means we have removed rt, we have removed new line characters, all these things we have removed. So let's see whether this function working fine. Yeah, so we have created a function now that will clean our tweets. Now let's clean our tweet. Creating a function is not enough, we have to clean our tweet as well. Okay, need to explain the 16 cell, line 16, cell 16. There is no cell 16, Sandhya. Any cell 17? I think you must be talking about. Yeah, I'll paste the code. Yes, 17. Okay, 17. I'll tell you. Until then, guys who are doing with me, please write this code in your system and let me and please check whether this is working fine for you in your system or not. Okay, in line number 17, what we have done is there is a pandas library and we have imported the pandas library as PD. Okay, you can go above and you can check. This is the pandas library. We have imported pandas library as PD. And in case of cleaning of the data and missing values consideration and all those things, we require data frame. Okay, we require data to be converted into data frames. Okay, data frames are objects in pandas. Okay, so I took the help of pandas library and I converted our list tweets underscore list into the data frame that with the name tweets underscore two underscore df. Okay, and this is the data frame. This is how the data frame looks like. Now what I can do anything on the data frame because I can remove at the rates. These things I won't be able to do if it was a list. Okay, uh Mohammed, that won't be possible because it's been 40 minutes that I have been explaining, so I can't explain it from start. But you can watch the recording. The recording will provide it to you. I think you can watch the recording, or I in the end I will give you or I can give you a quick recap if you can understand. We although we have done nothing much, we have just imported a few things, imported libraries. This is the first step that we have done. Second step is we have taken a list and empty list where we will keep the tweets. Okay, and we have created this function which will append all the tweets. Okay, maximum 1000 tweets will be inserted. Okay, with the keyword crypto from January 2020 till today. All the top 1000 tweets will be appended in this tweets underscore list. And then what we have done, I have converted this tweets underscore list into the data frame. Good, Iqbal. Okay, so it's been converted to head we have seen. Okay, and clean function we have created. Now let's clean the tweet as well. It's not enough to create a clean function. It's We have to apply that clean function to our data frame as well. So I'll create a new column. Okay, let me create a new column with a name. Let me search of the name. So name maybe clean underscore tweets. Okay, clean tweets I want separately. So cleaned tweets, cleaned clean tweets. Okay, is the name of the column that I want. Okay, so what I want to do is I want to apply this clean tweet function on already existing data frame, and basically I want to apply what I want to do want I want from this particular data frame. This is the data frame that we currently have. I want a new column with in which contain tweets that are cleaned. Okay, and I will clean only these tweets and I will put them here. Okay, I will clean this tweet, I will remove this or enter it everything and I will put it here. This is what I wanted, so I'm writing the code for that. So tweet underscore df, and tweets is the column, and I want to create a column for here as well. Okay, it's got apply. Please just give me a second. I'll be back. Yeah. So I hope okay, and clean tweets, nothing much. Apply clean tweet function. Clean tweets. I think this would work and it would give a new data frame. Okay, it would give a new data frame. So this is a data frame. The data frame is same. It will give you a new column in the same data frame. Okay, as you can see, now at the rates, all those things have been removed, and these tweets looks pretty much fine, right, guys? So they look pretty much good, and we have removed all those things, right? At the rates, hashtags, all these things we have removed, right? Now, what we'll do next is, okay, please do it in your system and let me know in the chat when you are done with this, everyone. I have pasted this. I will paste this as well. I pasted the code in your chat and let me know when you are done. Uh, I can't see any. Aditya, okay, you still have at the rate left. Okay, I think there might be something wrong that you have. Okay, and it's yours. Yeah. So there might be something wrong with the regular expression that you have created in as you can see on my cell number 19. There might be something wrong that you must have done. Please check the syntax again. All the at the rates will be get should get removed. That's the thing. Search for at the rate who are remaining and try to match that particular string with the at the rate from the regular expression string that you have generated, right? Yeah, obviously he's checking clean to its column. Yeah. Okay, guys, done with everyone. Yeah, cool. Yeah, okay, then we are moving forward. Now it's cleaned. Okay, great. Okay, now we since we have the data ready with us, okay, it's 1,000 clean tweets we have. Okay, so what we'll do is we will uh, we will insert them into a CSV file. We will store them, as I told you. We'll store them in a CSV file. So let's do that now. Okay, so how to do that? We know that pandas come with a function named to CSV. Okay, so let's use that. Name of the data frame is this. So this is the name of the data frame that we have. Okay, it contains the clean tweets. So dot to underscore CSV is the function that we use in pandas. Okay, to import all the data to the CSV. Okay, let's name the CSV with something. Let's name it as tweets underscore crypto.csv. Okay, and you can see in the file structure I don't have any CSV file, but once I run this command it will be created there. Okay, so let's run this, and yeah, it successfully ran, and you can see a file has been created. If I open it, mm, like you can see tweets and clean tweets, they are all there, okay, in a CSV file. So now you know how to create a data frame, data file, data set for your coding, right? Once that is done, now I will start my process again. Okay, and okay, I'll start my process again, and I'll create another data frame because tweets underscore to underscore df, it's very big data frame. I want a short one, and I only want the saved tweets, and I'll start my process because till this it was data pre-processing that we have done everything. Okay, now we will start with data analyzing and data visualization part. Okay, so that was the one part of the data science project that we see. Now this is the second part of the data science project that we are entering to. Okay, so let's make a new beginning to the data science project. We have already seen how to save the database CSV file. We'll use the same CSV file in the data, and it will look like we are starting afresh. Okay, so that from the starting you know all the functions to use. Let's say there is some person who wants to start from the importing of the CSV file. Okay, so for that person I am starting, otherwise we could have used the same data frame. Okay, so let's start that. So let me create a variable. Let me create a variable that will store the database data frames. So tweets, save tweets is the variable, and I'll do for in order to read the CSV, we use read CSV function, right? read underscore CSV function, and the name of the CSV, the same thing. Okay, and we have to just mention that index column we are taking as 0. This is by this we have read the CSV, and now guys, you there are 2-3 terms that we need to understand. First is subjectivity, second is polarity. Okay, so how many of you know about this polarity and subjectivity? Can you write in the chat? Do you have any idea about polarity, subjectivity in terms of tweets, in terms of like general sense? Have any idea about polarity and subjectivity? Some people have. No, mostly you don't have. Yeah. So let's see that what polarity and subjectivity is. So starting with polarity is basically in the technical terms, it's a float number which lies in the range -1 to 1, both in which both are inclusive. Okay. -1 basically represent in terms of tweet I am talking about now. In terms of statements or tweets, statements you could say. So in terms of statement, its value rises from -1 to 1 mathematically. What it signifies in terms of statement is, one signifies that this statement is a positive statement. If a polarity of a particular statement is 1, it means that it is a highly positive or positive statement, I would say. And if it is -1, it would say that its polarity is a negative statement, or this is a negative statement, its polarity is -1. Cool. So this is what about polarity, right? What about subjectivity or subjective? So subjective sentence generally refer to personal opinion, emotion, or judgment, whereas objective refers to the factual information. So subjectivity is also a kind of float. Float is a float number mathematically, which lies in the range from 0 to 1, and it depends upon the personal opinion, emotion, and judgment. Okay. So these are the parameters that subjectivity hold. We don't have to go in much detail of polarity and subjectivity and how they are implemented. For our help, we already have this inbuilt values and inbuilt function that will help us. Okay, so we have imported text blob library. Okay, because of that, here you can see we have imported text blob, right? Because of that, we will get the values of subjectivity and polarity. So let's see how. So I'll create two functions. First function will give me subjectivity. Second function will give me polarity. Okay. So let's see that. So let's create a function for subjectivity first. So def get sub subjectivity, and I'll input the text. Okay. And what we need to return? We need to return. What I'll return is uh, text blob and text dot sentiment. Sentiment is a sub module, and inside the sentiment we have subjectivity. Okay, so the same code goes with polarity as well. Only the name will change. If instead of subjectivity, I have to write polarity. Let me go small polarity. Okay, and the same thing goes here. Polarity will. So we have created two functions that will give us polarity and subjectivity, just like we create a function that will clean the tweets. Now, creating a subject, as I always say that creating a function is not enough. We have to apply them. Okay, so we'll use the apply function as we have used to clean the tweets. Like we have used the apply function. We have selected data frame. We have selected data frame that we selected data frame and a column particular that we want to apply the clean tweets function. We will do the same thing here as well. Okay, so we have let's see the data frame that we have, right? We have not seen the data frame that we have. look, tweets, clean tweets. Okay, this is the data frame that we have. So I need to create another column with the name subjectivity and polarity. Okay, so for that I'll start writing. Let's write that and let's see how it goes. So tweets, save tweets, and in the bracket I'll write the name of the column. Let me name it subjectivity itself. Okay, subjectivity is the name of the column. So what basically I want is I want to create a column, two columns I want to create, one of subjectivity, one of polarity. Inside of like there will be four column now in this data frame: tweets, clean tweets, subjectivity, polarity. Four columns will be there. Okay, so data frame subjectivity is the name of the new column that I'm going to create, and I'll copy that. What I have to apply, I have to apply this function on clean tweets, right? Because now that this particular column is not of necessary, like tweets column is not at all necessary. I've just kept it just to compare and just to see whether they have this is what they have converted. Otherwise it is of no use for us. Okay, so cleaned tweets. So clean tweets and dot apply. What function we will apply? We will apply subjectivity, get subjectivity, right? So I'll copy that. Okay, and let's do the same thing for polarity, and then let's watch the data frame how it gets changed. Okay, so I'll write polarity and we'll write the get polarity function as well, and rest everything will remain same. Okay, now let's print the data frame that we have. What I can also do is I can I can drop this particular tweets column. Okay, so in order to remove that, I need a drop function. I'll use a drop function, and which column you want to remove. So the name of the column is tweets. Okay, how you want to remove horizontally or vertically, like a complete column you want to remove. So you have to mention x is equal to 1, and yeah, it will remove. And yeah, as you can see, the the tweets column has been removed, right? Because it was not at all necessary for us. So that's why it's all better to remove that. Now we have clean tweets, we have subjectivity, we have polarity of each tweets, right? So you can now, it's very interesting, guys. You can check whether this particular never win from no and no win all. What is this tweet? Okay, it has subjectivity of 0.4 and has a polarity value of point minus zero point 0.4. It means that it is a bit of negative tweet. It will be counted in a bit negative tweet. Cool, guys. So let's take so we are done with this, guys. Are you done with this? I'll copy paste in the chat. Let me know in the chat if you are done in your local system with this. We'll move forward. Done. Okay, sure. So subjectivity is it's a tweet. It's a float value. Okay, it ranges from 0 to 1. It depends upon emotions and sentiments of the people for that particular statement. Okay, it values right from 0 to 1, both inclusive. Okay, and polarity is a value from -1 to 1, and uh, it tells whether the statement is positive or negative. Okay, on the basis if the more positive is the value of the polarity, it the more positive is the statement. It is assumed like this. Okay. Okay, guys, then I think we would start then if you all are done with this. Okay, then now we have done with polarity and subjectivity. Let's do take the use of that. Okay, because that's what our ultimate aim is. We have the polarity of each column, each tweet. Now we want to check how many are negative, how many are positive, and all, and how many are neutral, right? So let's create a function to check that. Okay, so I'll create a function, def and get analysis. Let be the name of the function as get analysis, and I'll pass the score in this. Okay, and inside this, what's the score? It's a text data. It will be in the form of like polarity, or let's say this score will be polarity. Okay, this score is a polarity value. Let's say minus zero point 0.5. It's inserted. So if the score that or the polarity value is less than zero, so what we will return negative. Okay. Else if the score is having zero value, right, it means it's a neutral. Okay, capital and capital. Else if it is a the last case is if it is a if it the score value is positive, so it will return positive value. Okay, so we have created a function that will check whether the statement is negative or positive, based on that, based on the polarity value. Okay, we just have to insert the value inside this function and it will give positive, negative, neutral. Cool, guys. So yeah, let's create another column which will store negativity, negative, positive, or neutral statements. Right? Let's create a column on the right side of the polarity. Okay, we can do that. We know how to do that. We have done it many times. I'll copy this particular line. I'll because we have to apply the function again. Now this time, which function we need to apply? Get analysis. Sorry, get analysis function we need to apply. We need to apply get analysis function. What is the name of the column we want to create? Let's name it analysis itself, because we have done analysis. And what is the column that we need to work on? Clean tweets? No, we have to work on polarity. Okay, we want polarity, and with the P capital, I guess, because the name in the column name with the P is capital. Yeah. Okay, guys. So let's run this and let's hope for the best. Right, it's running. It's also running. Yeah. So let's print that. Okay, let's see how the data frame looks like now. This is how it looks like: polarity, neutral, positive, negative, positive, positive, all those stuff. Okay. Cool, guys. So yeah, if we let's say if I want to count how many positive are there, neutral are there, how many negatives are there in this particular data frame. So there is a function called value count, value underscore counts. So let's use that. So save tweets in on the analysis column. I want to apply value count, and hope this will generate the values. Value counts, it's not count. Value counts, yeah, you can see there are 603 positive tweets, there are 211 neutral tweets, and there are 187 neutral tweets. Guys, are we clear with this till now? Because we are jumping into data visualization. So have you written the code till now and you are getting correct answer and everything? Are we cool with this till now? Just let me know in the chat and we move forward with data visualization. This is for everyone, not for people who are just writing the code. This is for everyone. Please give a Y or an if we are cool or not cool. Got the similar result? Yeah, the results will be similar, might not be the same because it depends upon the keyword. It depends upon Meanwhile someone has tweeted something onto using that, right? So it depends upon many things, so that's why the result might change, but the concept will remain the same. Okay, just remember the concepts, understand the concept. Clear? Great. Okay, yeah. Does this mean in Twitter most of the people are talking positive about crypto? Yeah, top 1,000 tweets at least tell that. So that's why doing the sentiment analysis. You can do the same thing for Amazon reviews. You can do the same thing for other stuff as well. Like there is endless application of data science nowadays. So yeah, we'll also plot this and beautifully now. Okay, so yeah, let's start. Let's do our bar plot for that. So let's do a bar plot. Right. So which library we use, right? Matplot and plot function we use for plotting purposes, right? So let's use that itself. And yeah, so let's name the figure. Let the figure give a name, and we use the plot library plt.figure, right? And inside the figure, let's keep the figure size. Let me give the figure size. Figure size. Let me give it a size of 7 by 5. You can give it anything. It will hardly change. And so I'll create a bar plot. So there will be three bar charts. Okay, so three different color I want to give. Okay, so let's give it very smartly. Like for positive, I will give green color. Okay, for negative, I will give, or let's say for neutral I will give gray color, and for negative I will give red color. Okay, so it is easily distinguishable. Now, what all things we need to plot? So need to mention that. So save tweets is the data frame I want to plot, and I want to plot the analysis column from that. Okay, and I need to do the value counts for that. What I need to print is value counts the values, and because this is the value that we want to plot, like bar chart, right? We want to plot, the plot will be 603 higher for positive, 211 height will be the plot for neutral, and 178 for negative, right? That's what we wanted. So value plots, and then we need to route the plot. We need to plot this, and what kind of plot we want. So need to mention that bar plot is what we want, and the color combination we already have. We have already created a color list, so we want this color combination, right? Done. We are mostly done. Let's beautify this as well. Let's directly plot that, and let's beautify it after that. Okay, so plot dot show. Let's see how it looks like, and you can see it's beautiful, right? Right, guys? But it's not that beautiful. There is no X label, Y label, title. There is also grid back in the back side, so need to remove that. So let's do that now. Let's put the title first. So plot dot title. What title should we keep? Let's keep it value count. That what it is, value count of tweet polarity. And let's give us as the X label. X label on the X axis. We'll get a label. So X label, maybe it may be count, and let's give the Y label as well. Let the Y label be, let's say, polarity. That's what it is. Or let's X label be polarity. Yeah, X label will be polarity, and Y label will be, I think, the count. Yeah, correct. Yeah, and let's remove the grid as well. So plt dot grid is the function, and I will make it false. Okay, so this grid is these backward lines, background lines that will be removed. Okay, as you can see, it's now looking a bit good. Okay, count is there, polarity, now it's easily visible. Cool, guys. So this was data visualization. Cell 32. Okay, 32. Yeah, In cell 32, cell 30 we have it's simply head. Head is the function that will print the top five values of this particular data frame. Okay, with the help function. Let's say I want to print the top 10 values of this data frame. I'll write 10 here. So top 10 10 values will be printed. Top 10 data frame values will be printed. Top 10 data frame. Yeah, cool. Okay, guys. So clear, everyone. This was the data visualization that we have done. Now, mm, just give me a minute. You can write this. Okay, I'll copy this code in the chat so that you can write it on your own system and run it and let me know once we are done with this. Okay, please do it on the same hand because it would be of your great help. Like after the session, you have your own notebook. Although I will share the notebook, I will share the presentation as well. But again, if you have your own notebook, it would be really great. It will boost your confidence, nothing else. Done, got it, everyone? Completed it in your local system? Yeah, waiting for you. Okay, cool then. Yeah. So we have plotted a bar plot. Uh, what else we can do is, although we can do many things, but yeah, yeah. Now let's get. We can plot the pie plot as well. We can plot the scatter plot as well, but not let's not waste our time in doing that because we have a more important task to do. We have till now we have not broken down these. We have not used the concept of NLP, right? So let's use that. Let's come to the main part what we have studied, right? So let's break each tweet into the words. Okay. So what I'll do is I'll break each tweet into each tweet sentence into words. Okay, so I'll take an empty list. Okay, that will contain the sentences. Okay, so for I'll apply the forward on the clean tweets. I'll move on each of the clean tweets. Okay, I'll iterate over the each tweet and I will insert them in the sentence. So what my aim is, I will first I will take this tweet. Okay, and I will insert this into the list. Okay, and then I will iterate over this list and I will broke down into the words. Okay, right, and each word I will store in the new list. Okay, that's what I will do. So let's do that. Let me show you with the, so two for loops I would require, right? So for in uh, the data frame save tweets, and which column we are, clean tweets is the column that we are going to iterate over. Okay, and what we need to do in this, uh, I need to just simply append sentences in this. So sentences dot append, and what I need to append is word. The word I need to append. Okay, and now just come out of the list, and so what the sentences would contain. Let's see that. The sentences would contain the same thing that we have done now. All the list in the form, this list, this sentences is a list that will contain all the tweets. Okay, so now what we are doing is we are creating uh, a list with the name lines. Okay, and we are splitting the words. Okay, we are splitting the lines. For a particular line we are splitting it in the form of words. Okay, let's see that. So let's create a list using the list function. Lines is the name of the list that we have created, and for line in sentences. Okay, for lines in each sentence, so we'll pick up first tweet, and what we'll do with that, let's see that. So words equals to line dot split, and we'll split that particular sentence. Okay, and now we'll iterate over this word as well. So for w in words, okay, for w in words, we'll write lines dot append. Now we are using line. Okay, lines dot append w. Okay, so each word we are inserting, and let's say I want, so my lines list has contained all the words. So let's say I want to let's say I want to show you the first 10 words in the first tweet. For first 10 words in the first tweet, I'll write like this, and you can see these are the first 10 words. Mm, in the first tweet, the first tweet is very above, so you can check that as well, right? So now let's come on to the important part. This is all what we know. We have done that many times, these things. Now what NLP and where we are using NLP, that let's come to that part. Okay, so basically we need stemming first. Okay, we need to stem those words first, right? So what type of stemmer we are going to use? So snowball stemmer, I think, would be a good idea to use here. Okay, so stemming all those words to their root words is our aim. Okay, so let's create the stemmer. So stemmer equals to snowball stemmer. That's how we have created object, right? And we have to write the language as well that we need. Remember in the last stemmer, that is snowball stemmer, we have to mention the language as well. So language I have written. So snowball, it's snowball stemmer. W is missing. Snowball stemmer. Yeah, snowball stemmer, and stemmer object has been created. Let's create an empty list that will store the stem, and for each word in the lines list, I will append that. So stem dot append. What we will append is the value of each stems. Okay, so stemmer dot stem is the name of the function, and we will iterate over each word. Okay, so it will append the root words of each stem, right? So let's see how they look like. First 20 stems, you can see these are the first 20 stems. Now as you can see, there are certain stop words or many common sentences, certain stop words in this as well. Okay, now if I want to remove that, how to remove that? So let's do that. Let's create another stem 2. Okay, so let's iterate over that. So for word in stem, okay, if that particular word, what I want to do is I want to remove the stop words now, because these are the stop words like dot 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 dot. These words are irritating, right? And other stop words are also there that we have seen yesterday, right? Yesterday there are already defined stop words in NLTK. So let's try to remove that. So what I'm going to do is, if that particular word, I'm iterating over the complete stem, and I'm seeing whether if this any particular word is there which is matching with the stop word. Okay, so if the word not in, basically not in, if it is in the stop word, we'll leave it, but if it is not in the stop word, we'll take it. So NLP dot false dot stop underscore words. Okay, so we'll take that. So stem 2 dot append. Okay, okay guys, so let's run that and let's see the value of stem 2 as well. Few words have been removed, few are still there. Like these are three dots. Some stop words have been removed. Like I have been removed. Right, all these stop words have been removed, which were already defined in NLTK library. We have not defined it separately. Guys, there is a two differences now that you need to understand. That in this case, when we removed certain words, right? When we removed certain words, that was our own wish. Mm, this was a library. This was a module, right? Uh, where we have written the regular expression now. I don't remember where we have written the regular expression, but when in this particular tokens, in this particular tokens, when we have removed such words. Oh, here itself, yeah. No, there itself. uh yeah, it was correct what we were looking at. After stop words we have removed the, yeah. So when we have removed this question mark, exclamation mark, this colon, semicolon, all these are the words that we have removed. So we have created a punctuation marks, we have used the regular expression library. So it's our choice that what we want to remove. But here it's the NLTK. In the stop word, it's all about the NLT. What are the stop words that are defined in NLTK library? We have also seen that yesterday. What are the stop words that are defined in NLTK library? Right, stop words in English in NLTK library. We have seen that. So these are the stop words. You can see I must be there. So that's, yeah, I must be there. So that's why I and all these words have been removed. Right. Cool, guys. Now let's create a new data frame because we have been playing with the data frame. We know we have created two stems. Okay, so let's create a new data frame, and because we are now going to plot the result. Okay, we are now going to plot the result finally. So let's create a new data frame. So df equals to pd dot data frame. Name of the data frame is df. Okay, pd dot data frame and stem 2. With the stem 2 we not create because stem 2 is the latest one, right? So yeah, let's count the value as well. So value counts, value underscore counts. It will count the values for that. No, no, no. Let's assign the df as this value counts. Let's assign df as this value. Let's store them in it. Okay. Let's see what new data frame is. As you can see, crypto is appearing 7774 times. Today is appearing 468 times. Today dot is appearing like this. Okay. Got it, guys. Now, uh, now what our aim is to plot the top 20 used words in first 1,000 tweets. That's what we are uh, printing. So it's very important from other company, like what is trending on the Twitter, so we can launch some product about this. Okay, you can keep the Amazon, okay, as the keyword, and Amazon can see if there are bad reviews or not, okay, on the Twitter, or someone has plotted, and what are the issues they have plotted. Like let's say if for top 20 words in this tweets, what I will get is crypto, today, and all those things that are already mentioned in the top. But if it was Amazon, okay, so Amazon can get a laptop, mouse, so it can come to know, okay, these are the laptops. Okay, laptop is the most trending word, and people are facing the issue in most of the laptops. People are facing most of the issues in mouse, regarding mouse. So it can improve on that. It can tell their engineers and their managers to work on that. Okay, that's how the sentimental analysis works. Okay, it's about the sentiments that people are putting on social media or stuff. Okay, and that's very useful, very useful. I can't tell you the how much useful it is, but yeah, it's very useful. So let's plot the 20 top 20 used words. Okay, so df equals to df, let's like slice it to 20. Let's slice the data frame to 20. Okay, now let's plot that. So plot dot figure, and let's assign the figure size that we do. So figure size, let it may be let's say 10 by 5. We wanted something big, right? And what we are going to plot, we'll use the CMON library, and we are going to plot the bar plots. Okay, so bar plot and df dot values and df dot index that we are going to use, and the value of alpha is 0.01. Seaborn is the library that is used to plotting as well, right? So let's give it a title as well. Let the title be top overall or top words overall. Okay, and let's give the X label as well. So on the X axis, we'll uh, let's keep the count of words. Okay, so the count of words let's keep on X axis, and I'll increase the font size of it. Font size to be 12. Okay, and I'll do the same thing for the Y label as well. Only the title will change, and it will in the X in place of X label it will be Y label, and the title will also change a bit. It would be word from tweet. The font size will be 12. Now let's plot that. Let's not waste most time. Error. Alpha. It's alpha. Oh my god. Oh, it's very light. It's very light. Are you able to see that, guys? It's very light. It's my system error. Guys, are you able to see that? Today NLTK words. Yes, yes, yes. Yesterday we didn't remove stop words. It was more of the unnecessary symbols that we removed. Okay, it was not the stop words. Okay, it was unnecessary symbols that we removed. Is clear with this? We have okay. So I think the plot. This is what the overall top words have been there. It would be looking good in your system. It's not looking that good in my system. The color is a bit light on my side, but the total count of the words you can see crypto is the most counted word. Uh, mm, yeah, you can use CSV data. You can use IPNB file. Yeah, you can use alpha point 4. Let's try that. Yeah. Thanks. Thanks, Aditya. Yeah, done. Now it must be visible. Yeah, great then. I think that was all from our project, and that was all from our side. And just give me a second, and I'll let me know what doubts if you have any doubts, and I'll try to resolve that. Okay. I want top trending tweets. What I should modify in this? Uh, top trending tweets, like in which topic or in which keyword? With which keyword? That is, yeah, we are filtering with crypto basically. So you can remove the filter, I think. Or you can filter it according like cricket or whatever you want, sports, football, BMX, whatever you want. Right, guys? I hope you enjoyed these two parts of the session, right? Yesterday and today we have built a complete project, and you can just show this to manager or stakeholders, whatever you want to show them. Cool. Thank you. And there is one important thing that I want to show you. That is our Learnbay website. You can go to our website. There are uh, courses for professionals. There are courses for college students as well, so you can just give it a try. Okay, and the courses are good, and you can give it a try on that. Do explore that. I'll paste that in the chat for you, and you can, for more sessions, you can subscribe to the social media channels of Learnbay. And yeah, you can see the list of the courses available here regarding data science, AI, ML, full stack, master program. You can, there are tons of courses. You can just go there and apply. You will get certificates. It's supported by engineers. Yeah, done. Thank you. Cool, guys. Then, yeah, I think that was all from our side.